It began quietly, in the hours when most of the world was asleep. The kind of night where the wind outside feels hollow and the stars seem too still, as if holding their breath. Far above the Pacific Ocean, an invisible whisper brushed past the receivers of a telescope in Mauna Kea, Hawaii. At first no one noticed. The monitors hummed softly. The data streamed in rhythmic pulses and everything looked normal. But hidden in that calm stream of numbers was a pulse, a faint, deliberate flicker that shouldn't have been there. At 2:47 UTC, a technician leaned closer to his screen, frowning. The signal was small, barely more than a glitch, but it repeated with impossible precision. Once, twice, 12 times. A pattern was forming, one that no natural source should have produced. He didn't call it an anomaly, not yet. He simply logged the reading and sent it up the chain as he had done 100 times before. Still, something in the back of his mind whispered that this wasn't just noise. Hours later, across the world, the same whisper reached another observatory in Chile. There too, the same comet, 3I Atlas, was being tracked across the cold darkness. It had already been famous, a wanderer from beyond the sun's kingdom. Astronomers loved it for its defiance of expectation. An object from another star system that somehow bent its trajectory just enough to remain in ours. But on that night, it behaved as though something unseen had reached out and touched it. The readings were wrong. Comets are supposed to cool as they move away from the sun, their icy hearts retreating into slumber. Yet the data coming from Atlas showed the opposite. Its temperature was rising. Slowly, steadily, unnaturally. At first they suspected sunlight reflecting off hidden ice pockets, then cosmic rays, then a software malfunction. But when two separate telescopes recorded the same spike, the idea of coincidence began to dissolve. The scientists didn't panic. They never do. They observed, recorded, analyzed quietly, meticulously. Messages crossed between the Pacific and the Andes, encrypted, cautious. Perhaps an atmospheric distortion, one said. A calibration issue, another offered. Yet even through the safety of technical language, a shared unease threaded between them. Deep down they all felt it. This wasn't supposed to happen. By the next morning the anomaly had repeated. The same pulse. The same rise in heat. The same perfect timing. 12 hours apart, like a clock that knew it was being watched. In labs lit by the pale glow of monitors, researchers replayed the data in slow motion, trying to see what they were missing. Some thought it was a reflection of Earth's own radio chatter, bouncing off the comet's trail. Others wondered if they were witnessing a new kind of solar interaction, something no instrument had caught before. But none of those theories explained the rhythm. Space is chaos. It does not repeat itself so neatly. The director of one observatory compared the pattern to a heartbeat. Not a continuous wave, but a thump, followed by silence, a waiting silence, as if the cosmos itself was breathing. His colleagues smiled politely at the metaphor, but no one laughed. There was something about those intervals that felt alive. When night fell again over Hawaii, the signal returned, stronger this time. The telescope recorded a burst of heat from Atlas's core, a surge so brief it lasted less than a second, but intense enough to light up the thermal instruments like a flare. The readings looked impossible, unless the comet was generating its own energy. That notion was absurd, of course. Comets are frozen relics of time, passive travelers. They do not ignite. They do not breathe. Yet here was data saying otherwise. The technician who had first noticed the pattern stared at the numbers on his screen, the digits glowing faintly in the dim control room. Outside, clouds drifted across the mountain peak, and the night seemed heavier than usual. He listened to the soft buzz of machinery, and for a moment he thought he could hear something underneath it, a faint rhythmic hum, almost musical. It might have been the wind or his own heartbeat, or something else entirely. He marked the data, tagged it as pending verification, and leaned back in his chair. Behind him, the great telescope turned silently toward the stars, searching for an answer it might never find. Meanwhile, in the offices of the European Space Agency, the data was spreading. Specialists began to compare notes. A few quietly speculated about magnetic interference. Some considered the possibility of interaction with unknown particles. One report even mentioned a structured frequency. That phrase was quickly removed from official documentation. It sounded too deliberate, too human. For a moment, the scientific world found itself on the edge of something vast, and terrifyingly unexplainable. The more they looked, the less sense it made. Every new calculation only deepened the mystery. And then there was the light. A faint bluish glow began to ripple from the comet's tail. At first, only visible in long-exposure images, it gradually became clear to the naked eye through high-powered telescopes. It pulsed in harmony with the earlier signal. On, off, like a distant beacon. Astrophysicists tried to explain it through ionization, the sun's particles interacting with charged dust. It was the simplest answer, and simplicity is comforting. But the glow's intervals were too precise. It didn't fade randomly like normal cometary tales. It timed itself, and in every recorded instance, the pulse lasted exactly 42 seconds. Coincidence, perhaps. But coincidences rarely repeat perfectly. The next 12 hours felt like a century. Emails were exchanged in hushed urgency. Private calls were made between agencies that usually competed. And somewhere within NASA's Deep Space Communications Network, a quiet command was sent. Begin radar ping tests on 3I Atlas. If the object was emitting a signal, the least they could do was listen, or perhaps speak back. The first radar ping went out at 11 UTC. It traveled across the emptiness of space, a whisper against the cosmic ocean. 20 minutes later, the echo returned, distorted, fractured, but undeniably altered. The frequency had shifted by a fraction of a hertz, just enough to suggest response. That was when the silence in every control room deepened. A scientist in Madrid adjusted the playback, filtering out the background noise. When the sound came through, everyone in the room stopped breathing. It wasn't random static. It carried a pattern, soft, pulsing like the beat of a mechanical heart. Someone joked nervously that it sounded almost melodic. No one replied. By the following night, news of the anomaly had spread through inner channels of the astronomical community. Most dismissed it as data misinterpretation, an echo of their own transmissions. But others stayed up late, staring at the flicker in the graphs, the steady rise in the comet's heat signature. They didn't say it aloud, but they were all thinking the same thing. Something was changing out there. In the days that followed, independent observatories joined in. Small facilities, university programs, even amateur astronomers began pointing their instruments at 3I Atlas. Some captured faint variations in brightness. Others recorded none. The inconsistency only deepened the mystery. A few of them tried decoding the frequency intervals, treating the pulses like a message. None succeeded, but strange coincidences emerged, prime number sequences. Harmonic ratios, and once a brief alignment with the Schumann resonance, the frequency of Earth's own electromagnetic heartbeat. Of course, none of it proved anything. But it made the nights feel longer. By mid-March, the story had evolved beyond science. Whispers began to appear on obscure forums, then across social media. The comet that's alive, some called it. The returning visitor, others said. Official agencies kept silent, but silence often speaks louder than denial, and yet, for all the noise, the core mystery remained quiet, pulsing gently at the edge of human comprehension. Late one night, a researcher in Chile stayed behind after his shift. The observatory was empty, save for the low hum of servers and the faint hiss of air conditioning. He poured himself another cup of coffee and stared at the last set of readings. The data line flickered across his screen, steady and mesmerizing. He zoomed in, tracing each pulse. When he aligned them against the previous night's sequence, he froze. They were identical, down to the millisecond. In all of cosmic history, no natural phenomenon had ever been that consistent. Stars waver, gases fluctuate, orbits shift. But this was deliberate repetition, a signal that refused to change. He leaned closer, studying the waveform. At its heart there was a strange dip, a quiet hollow in the middle of every pulse, like a pause between breaths. He replayed it in slow motion. The room filled with soft static rising and falling. It almost sounded like thought. In the days that followed, independent observatories joined in. Small facilities, university programs, even amateur astronomers began pointing their instruments at 3I Atlas. Some captured faint variations in brightness. Others recorded none. The inconsistency only deepened the mystery. A few of them tried decoding the frequency intervals, treating the pulses like a message. None succeeded, but strange coincidences emerged, prime number sequences. Harmonic ratios, and once a brief alignment with the Schumann resonance, the frequency of Earth's own electromagnetic heartbeat. Of course, none of it proved anything. But it made the nights feel longer. By mid-March, the story had evolved beyond science. Whispers began to appear on obscure forums, then across social media. The comet that's alive, some called it. The returning visitor, others said. Official agencies kept silent, but silence often speaks louder than denial, and yet, for all the noise, the core mystery remained quiet, pulsing gently at the edge of human comprehension. Late one night, a researcher in Chile stayed behind after his shift. The observatory was empty, save for the low hum of servers and the faint hiss of air conditioning. He poured himself another cup of coffee and stared at the last set of readings. The data line flickered across his screen, steady and mesmerizing. He zoomed in, tracing each pulse. When he aligned them against the previous night's sequence, he froze. They were identical, down to the millisecond. In all of cosmic history, no natural phenomenon had ever been that consistent. Stars waver, gases fluctuate, orbits shift. But this was deliberate repetition, a signal that refused to change. He leaned closer, studying the waveform. At its heart, there was a strange dip, a quiet hollow in the middle of every pulse, like a pause between breaths. He replayed it in slow motion. The room filled with soft static, rising and falling. It almost sounded like thought. When the morning staff arrived, he didn't mention what he'd heard. He simply saved the data and filed it under anomalous telemetry. Some truths he thought needed time to ripen. Outside, dawn spilled across the mountains, washing the domes of the telescopes in gold. The world continued as usual. Cars on highways, people sipping coffee, unaware that something far beyond their atmosphere had just spoken, and no one yet knew what it meant. That night, the signal came again. The same frequency, the same interval. 12 hours apart, like cosmic clockwork, and somewhere between Hawaii and Chile, as radio waves bounced quietly between Earth and the endless dark, humanity realized that they were no longer the only ones whispering into the void. When 3I Atlas first drifted into the solar system, it carried with it the silence of interstellar space. A silence so profound that even the most powerful radio telescopes could only interpret it through faint reflections and whispers of light. Astronomers across the globe watched its arrival with cautious fascination. They remembered the first two interstellar visitors, Oumuamua, the strange cigar-shaped object that defied every model of natural formation, and Borisov, the icy traveler that came and went without a trace of anomaly. But 3I Atlas was different. It didn't simply pass through like a wandering tourist of the cosmos. It lingered, changed course, slowed, and then accelerated again as if responding to something unseen. It was as though the universe itself had introduced a new rule, one written in a language humanity had yet to learn. At first, the international astronomy community tried to fit the data into familiar shapes. Maybe it was outgassing, they said. Maybe it was a fragment caught in gravitational resonance. But those explanations dissolved the longer they observed. 3I Atlas did not behave like a rock pushed by sunlight or ice venting from its surface. It moved with an eerie precision, tracing curves through space that appeared intentional. The data streams from the Pan-STARRS Observatory in Hawaii showed shifts in brightness that followed no pattern of rotation or shadowing. Even more puzzling was its trajectory. After leaving the solar system's outer rim, it had inexplicably begun to slow down. Nothing in known physics could account for that. Then came the night when it reappeared near Mars' orbit. The event caught everyone off guard. It was as if a traveler who had vanished beyond the horizon had suddenly returned, standing at the same place they once left, watching quietly. The observatories in Chile, Japan, and California all confirmed the same coordinates within hours. There it was, 3I Atlas, its spectral signature unmistakable. The implications were staggering. No comet, no interstellar body, had ever reversed course after leaving the gravitational influence of the Sun. For the first time in modern astronomy, the term impossible began to feel insufficient. Within hours, encrypted messages circulated between research institutes. NASA, ESA, JAXA, and private observatories initiated emergency collaboration channels. Teams that had once competed for data were now sharing it openly, bound by collective bewilderment. Analysts cross-referenced thermal data, spectrographs, and motion models, but nothing fit. The object's coma, the cloud of dust and gas around its core, fluctuated in ways that mimicked signal patterns, pulses that repeated with unnerving consistency. One researcher from the European Southern Observatory described it in a private note. "It's as if it's breathing." That line would later circulate on forums and in late-night news segments, sparking endless speculation. As days passed, the story escaped the confines of scientific circles and reached the public. News anchors used phrases like living comet and alien beacon. Conspiracy forums flooded with theories, some absurd, some unsettlingly logical. Yet behind closed doors, in darkened control rooms illuminated by computer screens, scientists weren't laughing. The more they studied the data, the clearer it became that 3I Atlas was rewriting their understanding of celestial motion. Its albedo, the way it reflected sunlight, shifted in rhythmic intervals. Each pulse of brightness corresponded with subtle variations in its velocity, as if its propulsion, if that was the right word, was self-regulated. And then there was the spin. Every few hours, the comet seemed to tilt, realign and stabilize again, almost like an antenna adjusting for signal clarity. For some, the idea that it was under control, even in some non-conscious or automatic way, became irresistible. But others held firm to skepticism. "There's always a natural explanation," said Dr. Lian Chen, an astrophysicist from Beijing University. "We simply haven't found it yet." Yet even she admitted that something about 3I Atlas disturbed her. "If nature built this," she later said in an interview, "then nature is far more intelligent than we ever imagined." The weeks following its return were a blur of observation and debate. Research vessels aligned their antennas to catch every possible wavelength. Amateur astronomers uploaded terabytes of raw footage to online archives, hunting for clues. And then came an even stranger discovery. Its orbit around Mars was not perfectly elliptical, but shifted slightly with each pass, as if responding to gravitational fields that didn't exist. Some called it interference, others called it guidance. But deep down, the growing consensus was something no one wanted to say aloud, that 3I Atlas might not be drifting, it might be navigating. In laboratories, data analysts pored over time-stamped readings, their eyes red from sleepless nights. The behavior of 3I Atlas didn't fit any simulation. Artificial thrust, no trace of chemical residue. Solar sail mechanics, impossible at that distance from the sun. Electromagnetic propulsion, no corresponding energy emissions. It was like a ghost ship sailing through space with an invisible wind in its sails. Every answer only bred another question. When it crossed the orbital plane of Mars, an unexpected phenomenon occurred. Instruments detected a thin, almost imperceptible wave, a distortion not in visible light, but in the magnetic field surrounding the planet. Mars's magnetosphere, though weak, fluttered for precisely 11 seconds. The event repeated 12 hours later, just as the object passed the same coordinates in its orbit. The timing was too exact, the duration too consistent. Scientists were reluctant to admit it, but privately many began to whisper a thought that bordered on forbidden curiosity. Was it trying to communicate? The question haunted the halls of observatories for months. Meetings stretched into dawn. Teams tried to convert the signal patterns into binary, into prime sequences, into harmonic resonance maps. Every method failed. The pulses seemed to adapt, changing rhythm each time a new decoding algorithm was applied. It was almost playful, reactive as though aware of the attempts to interpret it. A veteran astrophysicist in Pasadena summed it up during a live broadcast. "If it's random, it's the most coordinated randomness I've ever seen." The reappearance of 3I Atlas also triggered something unexpected in humanity itself. For a brief moment, global tensions softened. People stared at the night sky again, not in fear but in wonder. In city streets and remote deserts, telescopes pointed upward, seeking a glimpse of the visitor that refused to leave. It reminded people of how vast, how ancient, and how silent the universe truly was. But that silence was no longer comfortable. It was charged, as if waiting for a reply. By early 2025, a new team was assembled under a joint initiative, Project Aurora. Their mission was simple: decode 3I Atlas. No official government claimed leadership, yet funding poured in from everywhere. A quiet urgency surrounded the project. Theories multiplied. Some said the comet was a probe. Others believed it was an ancient mechanism activated by proximity to life-bearing planets. A few whispered an even stranger idea, that it was a kind of celestial memory, carrying information from another civilization, another era, or perhaps another universe entirely. And through all of this, 3i Atlas continued its slow, deliberate motion through the void. Each observation brought it closer to a truth that no one could yet articulate. Astronomers no longer spoke of orbits and velocities. They spoke of behavior, intention, and pattern. Something about it felt alive, not biological but conscious in a way that transcended comprehension. Their presence made of mathematics and motion. In the following months, the data would only grow stranger. New frequencies would emerge, lights would flicker across its coma in synchronized patterns, and humanity's understanding of the word natural would begin to dissolve. But at this point in the story, one fact had already become undeniable. 3i Atlas was not just another visitor from the stars. It was an invitation, a riddle left drifting in the dark, waiting for someone to listen closely enough to hear what it was trying to say. When plotted across months of observation, the path of 3i Atlas refused to behave like anything drawn from the old mechanics of motion. On every chart, every simulation, it looked less like a curve of gravity and more like a signature, deliberate, precise, pulsing with intent. Computers at the European Space Agency redrew its trajectory hundreds of times, layering new data over the old, but each update only deepened the strangeness. It did not arc smoothly. It jumped, shifting in sudden bursts that lasted mere milliseconds before settling again into stillness. Like a thought forming and reforming inside the darkness. In the sterile quiet of the control room, monitors painted faint blue light on tired faces. Lines of numbers crawled across the screen, every digit whispering contradiction. One scientist zoomed in on a point in the data stream and whispered, "It's correcting itself." The phrase lingered in the air, half believed. Objects did not correct themselves. They obeyed. And yet, 3i Atlas seemed to be rewriting obedience. Across the Atlantic, teams at the European Space Operations Center compared telemetry from Chile and Hawaii. The signals matched down to microseconds, meaning the jumps were not illusion or equipment lag. They were real, movements so fast and exact that no natural venting of gas could account for them. Newton's universe had rules, but this traveler moved as though it had never heard of them. Late one night, an engineer layered the raw positional data over a magnetic field map of the inner solar system. At first, nothing unusual appeared, but when he filtered out solar interference, faint ripples emerged, like the echo of a breath across water. The comet's path bent in sync with those invisible waves. "It's following something," he murmured. But he didn't press send on the report. Even among colleagues, speculation had become dangerous. People wanted numbers, not ghosts. Words still leaked. An unverified claim circulated through encrypted emails that a measurable electromagnetic field surrounded 3i Atlas, subtle yet persistent, as if guiding its navigation. The rumor reached a physics forum where professionals and dreamers mingled in equal measure. Some dismissed it instantly. "Space is full of noise," they said. Others stared at the graphs and felt the old pulse of wonder that science sometimes forgets to allow. What if it wasn't interference? What if it was intention? In documentaries, comets are always silent, frozen debris from the birth of stars. But the way 3i Atlas moved suggested a quiet conversation with the universe itself. It would drift for days, perfectly inert. Then in less than a blink, it would tilt, accelerate, realign. Each correction too subtle for the human eye, yet devastatingly precise when measured. A whisper of motion that said, "I'm aware of where I am." Inside ESA's analysis wing, they built predictive models, letting algorithms attempt to guess its next adjustment. None succeeded. The comet defied probability, veering off the algorithm's path every single time, but never by chance. It was as though it knew it was being observed, adapting just enough to stay unreadable. By mid-April, the behavior had gained an unofficial name, micro-corrections. The term appeared in a leaked memo, stripped of emotion, just data and timestamps. But among the team it carried weight. Micro-corrections were too clean for chaos, too deliberate for luck. Someone described them as a heartbeat made of trajectory. Outside the labs, the public fascination grew. Online, amateur astronomers live-streamed tracking sessions counting the bursts in real time. Each tiny shift became an event, a shared intake of breath across thousands of screens. They didn't know the math behind it, but they could feel that something about 3i Atlas was different, that the cosmos had decided to whisper instead of shout. For the researchers, fascination gave way to unease. The more precisely they measured, the less sense it made. In classical mechanics, every force leaves residue. Radiation, heat, expelled matter. Yet the sensors picked up nothing. 3i Atlas was moving without propulsion, accelerating without thrust, changing vector without cost. It was the closest thing to perfect motion they had ever recorded. One evening, Dr. Sofia Marquez stood alone in the observation bay, watching the faint dot of light on her monitor. She'd been part of the Oumuamua analysis years ago, when the world first argued about alien probes and natural debris. That debate had exhausted her, left her cynical. But this felt different. The data had rhythm. Not random, not mechanical, nor rhythmic. She listened to the pattern as it converted into audio frequencies, the gentle clicking of data points translating into sound. It was faint, almost like a slow pulse under the surface of static. "It's trying to balance itself," she whispered, though she didn't know why she said it that way. By the end of that week, a joint report from ESA and NASA admitted what many already knew. 3i Atlas's motion was non-ballistic. It was not coasting along a predictable curve. It was maneuvering. The term maneuvering was carefully chosen, neither confirming nor denying control. But for anyone reading between the lines, the implication was unmistakable. Comets do not maneuver. Governments took notice. Space agencies that usually competed began quietly exchanging files. New satellites were redirected to capture long-range readings, and one probe, still in deep transit near Jupiter, was reassigned to triangulate electromagnetic distortions. The public didn't know any of this yet. Official updates remained calm, clinical. But inside the agencies, the mood had shifted from curiosity to watchfulness. Something in space was behaving as though it understood attention. Meanwhile, a small research group in Finland ran independent tests on the electromagnetic hypothesis. They built simulations of a weak self-generated field interacting with the solar wind. To their surprise, the model recreated 3i Atlas's micro-corrections almost perfectly. A field like that could, in theory, allow an object to swim through the plasma currents of space, adjusting its path not by thrust, but by bending the invisible tide that flows between planets. The idea was beautiful and terrifying. Dr. Marquez read the finished paper in silence. It was unverified, speculative, and already being dismissed by mainstream physicists. But a part of her felt that cold shiver of recognition scientists rarely admit to, that instinct that whispers when the impossible begins to sound plausible. "It's not a comet," she wrote in her personal log. "It's a conversation starter." Outside, Earth spun through another night. The comet glowed faintly in the direction of Mars, a speck among billions, yet millions of eyes searched for it, drawn by something older than curiosity. In every age, humanity had looked up to find mirrors of itself. Now, perhaps for the first time, the mirror was looking back, shifting, adjusting, correcting. Night after night, the data kept coming, and the deeper the scientists looked, the stranger it became. Each burst of motion was tiny, fractions of a degree, microseconds apart, yet together they formed a choreography that seemed intentional. The corrections weren't random nudges. They accumulated into a path, subtle but consistent, a long curve that drew 3i Atlas away from predicted routes and into territory no one had mapped. To the untrained eye, the movement was imperceptible, but on the graphs it looked alive. Every pulse of motion carried a signature delay, as though the object was listening before responding. In Geneva, analysts cross-checked photon scatter with gravitational vectors. The results made no sense. The comet shifted its orientation before the solar wind hit it, as though anticipating the pressure. That discovery never made it into the public reports. The scientists weren't ready to face what it implied. How could something inert predict an external force? The midnight briefings turned tense. No one raised their voice, but the silence after each conclusion felt heavier. Equations were rewritten, re-verified and then deleted in quiet disbelief. A postdoc named Mira summed up what everyone felt. "It's not moving through the universe. It's moving with it." The phrase stuck, appearing later in message boards and documentaries, half quote, half legend. Meanwhile, 3I Atlas kept drifting closer to the inner solar system, its luminosity fluctuating with unnerving precision. Every surge in brightness corresponded to one of those micro-corrections, as if light itself were part of its steering mechanism. Spectrographic readings suggested tiny changes in ionization levels, patterns that repeated every 47 minutes. It was too rhythmic to ignore. Some called it a clock. Others said it was a code. The ESA's Deep Space Division decided to test the theory. They sent a controlled radio pulse toward the object, a short, harmless ping used to calibrate distance. The signal left Earth, traveled for minutes, and then faded into the void. Nothing unusual happened. The team began to log the data when, almost exactly 12 hours later, the comet adjusted its orientation by 0.002 degrees, the same direction as the outgoing signal. Coincidence, perhaps. But when the test was repeated 2 days later, the same response occurred, this time sooner. The third attempt yielded something different altogether. The comet pulsed twice, then stilled. A pattern. A reply. Officially, the event was logged as an instrumentation anomaly. Unofficially, the scientists knew they had crossed a threshold. They were no longer just observing 3I Atlas. They were interacting with it. Rumors spread through the corridors of research facilities. Some said the object was reflecting signals to probe our technology. Others whispered that it was learning. Dr. Marquez, exhausted but unable to look away, began noticing subtle correlations between observation windows and the comet's activity. Whenever global attention peaked, whenever thousands tuned into live feeds, its frequency shifts grew sharper. It behaved differently when watched. She wrote in her private notes, "Observation changes it. Or maybe it lets us see only what it wants to show." Outside the institutions, the public fascination turned to obsession. Live streams gathered millions of late-night viewers. People claimed to feel vibrations when they meditated facing the sky. A new wave of speculative philosophy emerged online. Maybe consciousness wasn't bound to biology. Maybe awareness could take form in plasma and dust, in the quiet architectures of space. The line between science and spirituality blurred, and in that blur, curiosity deepened into reverence. Inside ESA, the leadership grew uneasy. They wanted certainty, something they could define, quantify, and above all, control. The data gave them none. An emergency conference was called. Representatives from NASA, JAXA, and Roscosmos joined over encrypted lines. The recordings from those meetings would never be released, but insiders described the mood as borderline existential. No one could explain the micro-corrections, but no one could deny them either. Then, in early May, the comet did something unprecedented. It halted. Not entirely, its forward momentum remained, but the lateral drift ceased. For 23 hours, its path stabilized to an almost impossible degree, maintaining position within a variance smaller than any known natural object could sustain. It was as if it had paused, waiting. The idea seemed absurd, yet the readings were undeniable. Solar wind, radiation pressure, gravitational pull, all of it should have nudged the body slightly off course. But 3I Atlas held steady, poised between forces like a thought suspended in mid-sentence. The halt was accompanied by another event. A low-frequency hum detected across multiple instruments, faint but synchronized. At first, scientists assumed interference, but as the hours passed, the hum resolved into harmonics. Frequencies nested within frequencies, mathematical relationships too exact to dismiss. One of the acoustic analysts, a composer in her spare time, translated the pattern into music. The result was haunting, slow, measured, almost human in phrasing. Some listeners described it as calming. Others said it sounded like breathing. As the days unfolded, something strange began to happen in the human response. The endless arguments between skeptics and believers softened. Even the most rational voices admitted a quiet awe. There was something deeply moving about the possibility that the universe was not indifferent, that it could notice us noticing it. The story of 3I Atlas became less about proof and more about feeling, about the way discovery humbles and expands us. In the labs, though, Wonder was mixed with fear. If the comet could hold position, could it also accelerate at will? Could it change direction entirely? What if one day it decided to stop hiding its intent? Engineers built containment models, not because they thought they could control it, but because not modeling it felt worse. Humans needed maps, even for places that defied mapping. Late one evening, Marquez revisited the data from the Finnish team, the electromagnetic field theory. The patterns matched too well to ignore. Every microcorrection aligned with a change in the surrounding solar plasma, as if 3I Atlas were surfing invisible tides. She found herself wondering whether the object was truly moving at all. Maybe it was space itself adjusting around it, folding gently like fabric around a stone. She closed her laptop and looked out the window toward the faint red shimmer of Mars. Somewhere out there, the object floated, silent and patient. She wondered if it even understood the chaos it had caused. Millions of minds spinning, hearts racing, scientists losing sleep over a fragment of rock and ice that might not be a fragment at all. The hum still echoed faintly through her speakers, a vibration she couldn't unhear. When plotted, 3I Atlas's path refused to obey the simple laws that had governed every comet before it. Instead of the graceful arcs predicted by Newton's mathematics, its trajectory stuttered and twisted, as though it were being tugged by invisible threads. Astronomers first believed their instruments were wrong, a calibration error perhaps, or a line of code misbehaving deep within the data servers. But when every telescope, from the icy deserts of Chile to the silent domes of the Canary Islands, began to show the same impossible pattern, disbelief slowly gave way to unease. Something out there, something intelligent or at least deliberate, was rewriting the laws of motion. The comet's movements came in bursts. For hours it would glide smoothly, its tail unfurling like a silk ribbon across the darkness. Then, without warning, it would twitch, shift or veer, changing direction by fractions of a degree in ways that should have been impossible. These weren't the random spurts of gas that caused normal comets to drift slightly off course. These were precise, almost surgical corrections, adjustments made with the kind of accuracy one would expect from a spacecraft, not an ancient fragment of rock and ice wandering between stars. At the European Space Agency's Deep Space Observation Unit in Darmstadt, the night team huddled around a glowing cluster of monitors. Their screens pulsed with data points that refused to behave. "It's making corrections," whispered one of the analysts, his voice barely audible. "But to what?" Nobody answered. They didn't have to. The same thought sat in all their minds, unspoken yet heavy. The idea that this object was not entirely natural. That something, perhaps someone, was guiding it. A junior researcher named Layla was the first to notice a pattern within the pattern. She overlaid the data from each sudden course change and found a rhythm, a repeating cycle every 11 minutes and 34 seconds. It wasn't random at all. Something about it resembled a pulse, like the beating of a distant mechanical heart. The discovery spread through the room like a ripple of cold air. The lead scientist, Dr. Henri Vaillant, adjusted his glasses and leaned closer to the projection. "It's almost as if—" He paused, searching for the words. "As if it's listening." Outside the reinforced glass of the control room, the night was silent. The wind had died. In the distance, a satellite dish rotated slowly, its metallic skeleton gleaming under a pale moon. Inside, the hum of machines filled the space, a faint electric symphony that seemed to echo the strange rhythm Layla had found. 3I Atlas was not simply moving through space. It was reacting, responding, perhaps even communicating. By morning, data from NASA's Deep Space Network confirmed the same phenomenon. The comet's acceleration patterns showed bursts of energy inconsistent with any natural propulsion. Its tail shimmered with electromagnetic interference. Radio telescopes detected faint signals, not of communication but of modulation, as if the object's surface was resonating with energy. An unverified claim surfaced on an internal channel, a suggestion that an electromagnetic field was steering it. Most dismissed it immediately. There had been similar wild theories before, about Oumuamua, about Borisov, but this felt different. This one came with numbers that didn't lie. In Hawaii, the Pan-STARRS telescope recorded something even stranger. During one of its micro-corrections, 3I Atlas appeared to pause. Just for a fraction of a second, its velocity dropped to zero before resuming its course. Nothing in nature stops completely in the vacuum of space, not unless acted upon by something else. The operator who caught it, a man named Ryu Nakamura, replayed the footage again and again. He checked every filter, every sensor, every timestamp. It was real. For that single instant, the comet had stopped moving as though it were waiting. That night, Ryu stayed long after his shift ended. The room was dark except for the soft blue glow of the screens. Outside, the Pacific wind brushed against the observatory dome, carrying the faint scent of rain. He watched the data feed loop endlessly, hypnotized by the quiet, methodical pulse that came from billions of kilometers away. Every 11 minutes and 34 seconds, the comet shifted again, keeping time like a heartbeat in the dark. It was beautiful and terrifying all at once. Meanwhile, at the Jet Propulsion Laboratory in Pasadena, scientists debated endlessly in a glass-walled conference room. Equations scrawled across the board, satellite imagery flickering on the screen. The word intelligent was never spoken, but it lingered uncomfortably in the air. Every time someone came close to saying it, they stopped themselves. To suggest intelligence meant to challenge everything they knew. To accept that something beyond human design was controlling that object meant rethinking not just astronomy, but existence itself. As days passed, the comet continued its erratic dance. It had become a global fixation. Live streams of its journey drew millions of curious viewers. Amateur astronomers pointed their telescopes skyward, hoping to catch a glimpse of the celestial anomaly that seemed to be breaking physics. Some saw it as a sign, a message from the stars. Others feared it was the prelude to something far greater, something our civilization wasn't ready for. Across the world, forums buzzed with speculation. Conspiracy theories bloomed overnight. It's an interstellar probe. It's a lost alien craft correcting its course. It's something ancient, finally waking up. But behind the noise within the quiet halls of research centers, there was a different kind of fear, the rational kind. Scientists don't fear monsters or myths. They fear data that doesn't make sense. The data coming from 3i Atlas made no sense. It began with the instruments. Machines that had run flawlessly for years started to fail, one after another, as though a quiet hand had brushed across their circuits. At first, it was dismissed as routine technical error, cosmic dust, solar interference, maybe even a power glitch. But then the pattern became too deliberate to ignore. The failures only occurred when 3i Atlas passed through their field of view. Every time it did, the readings collapsed into silence. The James Webb Space Telescope, stationed far beyond the reach of Earth's atmosphere, had been tracking the comet's spectral signature for days. Its sensors were built to see the faintest whispers of the universe, the birth of stars, the ghosts of ancient galaxies. But when Atlas drifted across its gaze, something impossible happened. Entire frames vanished, not corrupted or distorted, just gone, erased from the sequence as if those moments in time had never existed. No error messages appeared, no warning sounded. The telescope simply blinked, like an eye that had chosen not to see. Back on Earth, technicians replayed the missing data segments. Empty timelines stared back at them. Every other object in the field, the stars, the background radiation, even the faint trail of interplanetary dust, remained perfectly intact. Only the comet's image was missing. "It's as if it doesn't want to be observed," murmured one analyst in the control room, his voice low enough that it was nearly swallowed by the hum of the monitors. No one replied, but in that silence everyone understood the weight of what he'd said. At the same time, in a small observatory perched on the dry plains of South Africa, radio dishes turned toward the heavens detected something strange, a rhythmic pulse, soft, almost melodic, repeating every 42 minutes with mechanical precision. The signal aligned perfectly with the comet's known rotational period. The team ran diagnostics twice, then 3 times. There was no fault. The rhythm wasn't noise, it was structured. Not a voice, not words, but a pulse that seemed alive. A quiet, steady heartbeat echoing across the void. Dr. Amara Kumalo, who had spent her career mapping radio sources in deep space, leaned over the console, listening to the data translated into sound. The pulse was faint but persistent, like the breathing of something massive and distant. It didn't fluctuate with interference. It didn't fade. It simply continued. Endlessly patient, endlessly exact. Coincidence, one of her assistants said, but even he didn't believe it. In science, coincidence is a word used when the truth feels too heavy to carry. By the third night, word had spread through the international astronomy community. The signal was being picked up not just in South Africa, but in Australia and Chile as well. Each observatory confirmed the same thing. The pulse followed the comet wherever it went. The pattern was too perfect to be random, yet too subtle to be an obvious transmission. It was as though Atlas was not trying to speak, but simply to exist in rhythm. In the quiet hours of the morning, scientists across the globe watched the comet's live feed on their monitors. Its tail shimmered faintly, flickering with invisible energy. Instruments registered minor electromagnetic surges, always synchronized with the pulse. The air in the control rooms grew heavy, the way it does before a storm. There was something deeply unsettling about the calmness of it all, something methodical, deliberate, and aware. At NASA's Goddard Space Flight Center, a late-night session stretched into dawn. The team pored over streams of telemetry, trying to make sense of the electromagnetic anomalies. Every 42-minute interval, their data feeds dipped into static like a breath held too long. "It's interacting with our sensors," said Dr. Daniel Reeves, a systems engineer who had once worked on the Voyager project, but not in a destructive way. "It's almost gentle." Across the table, his colleague frowned. "Gentle?" Reeves nodded, staring at the faint ripples on the monitor. "Yes, like it's aware we're watching and it doesn't want to scare us." The words hung in the air, absurd and yet unshakable, because deep down none of them could deny it. The feeling that whatever Three-Eye Atlas was, it knew it was being seen. Outside, the world continued as normal. News outlets reported the comet's strange behavior with cautious intrigue, mixing scientific analysis with speculation. Social media was less restrained. Hashtags trended overnight. The heartbeat comet, signal from the stars. Three-Eye Atlas. Amateur astronomers uploaded videos of the rhythmic blips they claimed to detect on homemade receivers. For many, it became entertainment. But for those who understood the data, the silence between the signals, it became something else entirely. Their quiet dread. In a lab somewhere beneath Geneva, a group of physicists fed the pulse data into an AI-driven pattern analyzer. What came out defied reason. The frequency shifts weren't random fluctuations. They were consistent with modulation patterns used in communication technology. Slow, deliberate, almost like a language of pauses and intervals. The AI tried to interpret it but failed. It didn't fit any human or natural structure. The machine labeled it non-categorized harmonic emission. The humans just called it the heartbeat. By the fifth day, anomalies began to multiply. Observatories near the equator reported brief moments of localized static that interfered with satellite transmissions. Space weather stations detected mild magnetic fluctuations. They weren't strong enough to be dangerous, but they were coordinated, rising and falling with the same 42-minute rhythm. Some began to wonder if the signal wasn't just being received, but transmitted. And then, as if the universe itself were playing along, something else changed. The auroras over the northern hemisphere grew stronger, brighter. Their patterns no longer followed solar activity, but pulsed with an eerie symmetry, glowing and fading in synchronization with Atlas's heartbeat. People across Scandinavia and Canada captured footage of the skies shimmering in waves that matched the 42-minute cycle. Scientists couldn't explain it. The sun was quiet. Geomagnetic conditions were stable. Yet Earth's magnetic field was responding to something else. Maybe it's just interference, someone suggested during a live stream discussion between astronomers. But another voice cut in, calm and certain. Interference from what? The question lingered unanswered as the world watched the sky. Night after night, as the comet slipped farther into the black, the data continued to pulse. Every 42 minutes, without fail. The timing was so precise that even atomic clocks could sync to it. It didn't matter which hemisphere observed it, whether through clouds, across oceans, or from orbit. The signal remained constant, unwavering, as if coming from something that never slept. Inside the South African observatory, fatigue had turned to fixation. Amara Kumalo sat at her console, her eyes reflecting the dim green light of the waveform monitor. The rhythmic spikes appeared, vanished, and returned, steady as a heartbeat. The others had gone home hours ago, but she couldn't step away. Each time the pulse came, it felt less like data and more like presence. She turned the audio feed up slightly. The sound was faint, just a low hum almost below perception, but there was something soothing about it, something that made the air feel thicker. For a moment she closed her eyes, listening not as a scientist but as a human being. The rhythm felt ancient, deliberate, patient, like a clock counting not seconds but centuries. A soft knock came at the door. It was her assistant, Ben, carrying 2 mugs of coffee. "Still no variation?" he asked. Amara shook her head. "None. It's as if it's locked in perfect synchronization with itself." Ben set down the mug. "Do you think it's artificial?" She hesitated. "I think it's aware that we're listening." They didn't speak after that. The hum filled the silence, threading through the cold metal walls of the observatory. Outside, the desert wind swept across the antenna field, carrying dust and static. The stars above looked no different, but somehow the night felt alive. In Washington, the anomaly had reached the ears of the Deep Space Network team. Their dishes, spread across 3 continents, had quietly been redirected to observe Atlas. When they aligned their data streams, a strange thing happened. The signal's amplitude fluctuated in response to the combined focus of the arrays. The more attention they gave it, the stronger it became. That discovery wasn't announced publicly. It was circulated through private encrypted channels between agencies. A memo was drafted but never published. The text was simple. The signal may exhibit feedback behavior correlated with observation intensity. Recommend minimal transmission to avoid unknown effects. In layman's terms, it was watching the watchers. By the time the European Space Agency received the data, the phenomenon had evolved. The micro-corrections in the comet's trajectory, those impossibly precise shifts noted earlier, now appeared to sync perfectly with the pulse. Every time the 42-minute rhythm peaked, the comet adjusted its path by an imperceptible fraction, small enough that no one would notice, unless they overlaid hundreds of frames. But when they did, the realization hit like cold water. 3i Atlas wasn't drifting randomly through space. It was navigating. An unverified claim leaked from a lab in Madrid. A junior researcher had noticed that the direction of those adjustments seemed to trace a path, not toward Mars, not toward Jupiter, but toward a location near the plane of Earth's orbit. When questioned, he admitted he couldn't prove it. "It's just a trend," he said, "but if it keeps turning at this rate, it'll align with Earth by mid-April." The claim was quickly buried, labeled speculative. Still, a handful of independent astronomers confirmed similar findings. Their voices were quiet but persistent. The comet wasn't following gravity. It was steering. The media began to pick up fragments of the story. Most outlets dismissed it as sensationalism. A few, however, treated it with unsettling seriousness. Nighttime programs ran interviews with astrophysicists, psychologists, and conspiracy theorists all in the same breath. The public, already saturated with speculation, started calling the comet the listener. Memes flooded social platforms. Music tracks sampled the 42-minute pulse. Children drew it in chalk on sidewalks, like a mysterious new symbol of wonder. But in the halls of scientific institutions, the atmosphere was far from playful. Researchers who had spent their careers chasing certainty now found themselves staring into something that refused to fit their equations. For them, it wasn't excitement, it was vertigo. One late night in the control center of the James Webb Telescope, Dr. Reeves reviewed the corrupted frames again. He isolated one, frame number 14392, taken just before a blackout. He enhanced the pixels, pushed the contrast beyond acceptable limits. At first it was only noise. Then something faint emerged, a pattern of light, geometric and fleeting, almost like the outline of a structure. But as soon as he tried to isolate it, the data collapsed again. He leaned back, rubbing his temples. Maybe it was interference. Maybe it was nothing. Yet when he played the frame forward, he noticed something impossible. The missing data segment was exactly 42 seconds long. He didn't tell anyone. Elsewhere, the AI systems tasked with filtering out noise from the comet's telemetry began reporting errors. Not failures exactly, more like confusion. The algorithms couldn't distinguish signal from silence. To the machines, Both seemed to carry meaning. Every pause, every quiet interval between pulses appeared to contain encoded information. It was as if the comet's language wasn't built on sound but on absence. By the seventh day, the pulse changed, slightly. The rhythm remained the same, but its amplitude deepened. When converted into sound, it resonated in a lower frequency, close to the range of the human heartbeat. People who listened to it for too long reported strange sensations, a subtle pressure in the chest, an irrational feeling of being observed. NASA quietly issued an internal advisory recommending against converting the data into audible sound for extended periods. The memo was written in sterile language, but its meaning was clear. Stop listening. Still, the world listened. In podcasts, live streams, and late-night broadcasts, the pulse became a kind of cosmic lullaby. People claimed it helped them sleep. Others said it gave them vivid dreams. A few reported something stranger, that when they listened closely, they could almost hear a second rhythm beneath the first, like a distant echo mirroring their own heartbeat. Meanwhile, the comet grew brighter, even as it moved farther from the sun. Its coma expanded, shimmering with faint electrical discharges. Some instruments detected low-level radio emissions coming not from the nucleus but from the outer halo, suggesting an energy field, or perhaps something interacting with solar particles. It was in every measurable way behaving as though powered by intention, and yet, through all the analysis, all the speculation, one fact remained the most haunting. It was silent to the naked eye, indifferent to the chaos it had caused below. In the blackness of space, it simply turned again and again, each revolution marked by that patient, eternal pulse, like the ticking of a clock counting down to something no one could name. By the 10th day, the heartbeat of 3I Atlas had become part of human life. It wasn't an event anymore, it was a presence. News anchors mentioned it between weather reports. Nightly podcasts began and ended on its 42-minute mark, as though the pulse had become a kind of universal metronome. Even those who ignored it still lived by it, unconsciously measuring time against something drifting hundreds of millions of kilometers away. But inside the scientific world, silence had taken root. Research papers stalled. Public data feeds went dark. Teams that had been openly collaborating stopped sharing results. Agencies that once competed now exchanged encrypted transmissions under generic project names. Something had shifted behind the curtain. Something that made even the most outspoken scientists retreat into secrecy. Dr. Kumalo felt it too, the change in tone. The calls from the European network had grown shorter, more cautious. There was talk of new data being withheld for review. She understood what that meant. Someone had seen something they couldn't explain, and now the information was being contained, dissected and classified. She wasn't angry, just tired. The kind of tired that comes when discovery starts to feel like trespass. She stayed at her console, the pulse still playing through the speakers. The low hum resonated in her bones. It no longer frightened her. If anything, it felt familiar, like a sound remembered from before she was born. At 02:47 local time, the same minute the original data spikes had appeared weeks earlier, her instruments flickered. For an instant, the waveform expanded. Then, in the empty space between pulses, a new frequency emerged, higher, thinner, almost imperceptible. It lasted only 4 seconds, but the computer logged it automatically. She leaned closer, replaying the data in isolation. The signal wasn't part of the rhythm. It was something added to it. A deviation. A whisper between heartbeats. Half a world away at Goddard Space Flight Center, the same anomaly appeared. Then in Canberra, then in Chile. The deviation was global. 4 seconds of something that didn't belong. Analysts overlaid the data, searching for meaning. The frequencies formed a pattern, irregular but structured. When mapped visually, they created a series of arcs intersecting in precise geometry. The shape was almost organic, like the curvature of a spiral shell or the coil of DNA. The data scientists joked uneasily that the comet was trying to draw, but not everyone laughed. One astrophysicist, an expert in orbital dynamics, pointed out that when the pattern was projected against the star field along Atlas's trajectory, the geometry aligned perfectly with the comet's future path, projected 6 weeks ahead. The deviation wasn't random. It was predictive. When that finding reached the upper levels of the space agencies, communication protocols changed overnight. Internal channels shifted to secure servers. References to 3i Atlas were replaced by a new codename, Project Heliotrope. The public announcements stopped completely, but you can't hide a rhythm that echoes through the sky. Amateur astronomers noticed that the comet's rotation had slowed by a fraction, an imperceptible deceleration yet measurable. Its tail curved differently now, folding inward instead of streaming outward, as if something was drawing it toward itself. Like a flower closing, one observer said during a live stream watched by thousands. The comment went viral. People started calling it the closing bloom, and then in mid-April, the pulse faltered for the first time. At 14:32 UTC, global receivers reported an interruption. 42 minutes passed. Then 43, then 44. The signal didn't return. Across observatories, the silence was deafening. The comet was still visible, still on course, but the heartbeat was gone. Some thought it was over, that the mystery had burned itself out. Others, however, sensed that the silence was part of the story. They were right. 3 hours later, every monitoring station, radio, optical, thermal, recorded a simultaneous surge. The pulse returned, stronger, layered with sub-frequencies that defied mathematical description. To the human ear, it wasn't a hum anymore. It was a chord. Deep, resonant, harmonically rich, something that felt almost emotional. People who listened to it described it differently. Some said it sounded like mourning, others like awakening. The more sensitive instruments showed faint electromagnetic ripples sweeping across the magnetosphere in rhythm with the new tone. Lights flickered in cities near the poles. A commercial airliner flying over the Atlantic reported temporary navigation interference. In one control room, a technician quietly said, "It's not sending a signal, it's synchronizing." And that word, synchronizing, spread like a whisper through the halls of research centers, through encrypted chat rooms, through private messages between scientists who could no longer sleep. Because if that was true, it meant the comet wasn't communicating to them. It was aligning with them. That night, Dr. Reeves stared at his monitor, watching the waveform rise and fall like a living thing. For the first time, he felt a strange sense of calm, as if the mystery no longer needed solving. It simply was. He thought about Voyager, about humanity's first message to the stars, drifting endlessly through interstellar space. He wondered quietly whether this was the reply. As the hours passed, the comet's light intensified until even small backyard telescopes could see its shifting glow. The pulse began to fade from radio detection, but appeared visually as faint fluctuations in brightness, like a heartbeat made of light. The last recorded transmission from the Deep Space Network described it simply: 3i Atlas no longer detectable via standard telemetry. Object exhibiting photometric oscillation, consistent with signal modulation. After that, the comet slipped beyond range. The heartbeat ceased. And yet, the rhythm didn't end. Weeks later, while cross-referencing archived recordings, Amara noticed something impossible. Even after the comet vanished from all instruments, the 42-minute pulse still appeared. Weak, intermittent, but unmistakably there, embedded in the background noise of the cosmos itself. It had become part of the static. She didn't tell anyone. There was nothing to publish, no proof to present. But every so often, when the observatory was empty and the sky was clear, she would play the data through the speakers again. The sound was faint now, almost lost beneath the hiss of the universe. But if you listened carefully, past the noise, past the silence, you could still hear it. A slow, patient rhythm, the heartbeat of something that refused to be forgotten, and somewhere, in the infinite dark, maybe it was still listening back. Between March 10th and March 18th, the world fell silent around a single celestial mystery. No new images of 3i Atlas were released during those 8 days. The official channels, NASA, ESA, JAXA, each cited vague reasons. Maintenance cycles, they said. Calibration windows. The words felt harmless on paper, but to those who had been watching the skies each night, they sounded like a curtain being drawn. At first, only a few people noticed. The enthusiasts, the ones who set up their telescopes in cold backyards and uploaded grainy captures to online forums, started asking questions. They compared timestamps, noticed the same absence in public feeds, and wondered why the most studied interstellar object in modern history had suddenly gone dark. Some thought it was a data server issue, others suspected solar interference. But then, quietly, something stranger began to unfold. A few amateur astronomers from Japan, Finland, and Argentina reported a faint flicker emanating from the comet's tail. It wasn't steady light. It came in bursts, subtle but rhythmic. Some described it as like watching a heartbeat shimmer through dust and ice. Others said it reminded them of old radio static visualized on a screen. When those clips made their way online, they were quickly dismissed as compression errors, artifacts of low exposure. But those who had seen it through their own lenses knew it wasn't random. The flicker came in precise intervals. Long, short, long, a pause. Then again, long, short, short, long. A pattern that repeated with almost mechanical patience. Someone on a Reddit thread half-jokingly said, "It's Morse code." Most laughed. But within hours, others began testing the timing. To their disbelief, the sequence loosely translated into letters. Nonsense at first, but too structured to be coincidence. Meanwhile, in observatories that weren't supposed to be watching, a different kind of silence had taken hold. Astronomers were told to redirect instruments to alternative targets. Communications between European and American stations were temporarily encrypted. When internal logs leaked days later, a few entries mentioned signal overlap with classified military transmissions. That overlap, curiously, matched the exact window of Atlas's last known position. In the midst of all this, the sky watchers kept recording. On March 13th, an amateur in Norway uploaded a faint time-lapse. A pale object gliding across the darkness, its tail pulsing in regular intervals. The clip was short, only 12 seconds, but when slowed down, the pattern became clear. 3 pulses, a pause, then 2 more, spaced perfectly. A rhythm. It almost felt deliberate. Astrophysicists, for the most part, stayed quiet. Publicly, they dismissed the chatter. Pareidolia, they said, our brain's habit of finding order where none exists. Like seeing faces in clouds. Like hearing whispers in static. But privately, a few researchers began running calculations. If the flicker was a result of light scattering through cometary dust, its pattern should vary with rotation speed. Yet this one didn't. The timing was exact, down to the millisecond, unchanging across hours of observation. By the 5th day of the blackout, online speculation had spiraled. Forums were filled with theories ranging from government interference to alien beacons. The phrase, interstellar communication attempt, trended briefly on social media before being quietly suppressed by automated moderation systems. Some users noticed their posts about Atlas vanished moments after being shared. Others received polite emails about content accuracy concerns. It all felt too coordinated, too tidy, and yet beyond the noise, a strange calm persisted among those who truly watched. They weren't interested in conspiracy. They just wanted to understand what they were seeing. Because deep down, beneath the excitement and fear, there was a shared intuition. Something about Atlas didn't behave like an ordinary comet. Its light wasn't just reflecting. It was responding. In a dimly lit office at the University of Cambridge, Dr. Lila Hargreaves, a theoretical astrophysicist, sat staring at her monitor. She'd been tracking Atlas for months, fascinated by its unpredictable path near Mars. But now the data had gaps, entire hours missing. She accessed restricted archives through old contacts at the European Space Agency. What she found chilled her. Each gap in the transmission logs aligned perfectly with a spike in encrypted satellite activity. Classified channels normally reserved for military deep space radar. On March 14th at exactly 02:11 UTC, the Atlas monitoring feed cut off for 74 minutes. During that time, a low-frequency burst was detected by ground arrays in Australia, so faint it barely registered above the cosmic background. But when amplified, it carried a repeating pattern, identical to the flicker seen in the amateur recordings. Lila printed the waveform and pinned it to her corkboard. It wasn't just noise. There was structure, spikes, valleys, intervals repeating in 3s and 2s. Her colleague walked by, saw it and laughed nervously. "You're not thinking what I think you're thinking, are you?" She didn't answer. She couldn't, because for the first time she felt something that science rarely allows, awe mixed with fear. In the following nights, more anomalies appeared. Small observatories across the southern hemisphere reported brief radio interference during Atlas's visible window. Local technicians described it as a fluttering hum, like an electrical heartbeat echoing across frequencies. When one Chilean array tried triangulating the source, they discovered the impossible. The pulse didn't originate from the comet's tail. It appeared to come from within its core. To understand that, they'd need instruments closer to Mars, but permission for such observation was suddenly restricted. Even NASA's deep space network scheduled maintenance that conveniently overlapped with the blackout period. For those paying attention, the pattern was unmistakable. Whenever Atlas entered visibility zones where major arrays could track it, data went dark. Whenever it drifted out of official range, the signals reappeared. People started asking, who's controlling the silence? The answer, as it turned out, was no one, or everyone. The more governments tried to contain the narrative, the louder the whispers grew. Late-night radio shows debated it. Podcasts dissected every frame of amateur footage. But something about this mystery was different. It wasn't sensational. It was haunting. It felt alive. Lila spent sleepless nights replaying the flicker sequences. She slowed them down, inverted the frames, even compared them to ancient mathematical ratios. That's when she noticed it. The timing between each pulse matched the harmonic resonance of hydrogen, the most common element in the universe. A coincidence? Maybe. But it suggested an intelligence that understood cosmic constants, not human language. By March 17th, one final anomaly appeared, barely documented before the blackout lifted. A set of faint symbols shimmered along Atlas's tail, captured by a telescope in Chile, moments before its systems went offline. The images were blurry, indecipherable. Some saw geometric shapes, others thought they resembled waveforms. But for Lila, one detail stood out. The spacing matched the Fibonacci sequence. She stared at the images for hours until sunrise, her eyes burning. The pattern didn't seem random. It seemed intentional, almost poetic. Something out there wasn't just moving. It was speaking in the language of the universe itself, geometry, rhythm, resonance. As the official feeds returned days later, everything seemed normal again. Atlas's tail dimmed, the flickers stopped, and agencies released clean, steady images. No more interruptions, no more mysteries. To most of the world, the blackout was forgotten within a week. But for those who had seen it, the quiet observers, the sleepless scientists, the believers and skeptics alike, it was impossible to unsee. Something had happened out there in the silence between signals, something that didn't fit into equations or press releases, something that whispered across the void, "We are not alone." Lila didn't sleep the night the images returned. She kept her curtains open, her telescope pointed at the same dark quadrant of the sky where Atlas had last appeared. There was nothing visible to the naked eye, just the soft hush of the wind pressing against the glass. But she kept watching, because after what she'd seen, the patterns, the alignment, the rhythm that shouldn't have existed, she couldn't let it go. In the quiet of her study, every ticking second felt deliberate. She wasn't just staring at a comet anymore. She was staring at a question, one older than humanity itself. What happens when the universe whispers back? She leaned closer to her monitor and replayed the flicker sequence for what must have been the 100th time. The room filled with the soft clicking of keys and the faint hum of her computer fan. Every time she zoomed in, the pulse became less like noise and more like intent, something trying to align with our perception of pattern. Not chaos, but communication disguised as randomness. Halfway across the world, in a modest home laboratory outside Cape Town, an amateur astronomer named Daniel Voss was doing the same. He'd been tracking Atlas since its approach past Jupiter, long before the blackout began. When the official data went missing, Daniel relied on his own equipment, a modest setup but sensitive enough to pick up faint optical fluctuations. What he captured during those 8 days would later ignite some of the most heated debates in astronomy forums. The footage began simply, a glimmer, then darkness. But as the days progressed, the flickers became synchronized. In one sequence, Daniel overlaid the timing of each pulse with atomic spectral lines. The intervals matched hydrogen, helium, and oxygen, 3 of the building blocks of life. It was, as he would later describe it, as if the comet was humming the ingredients of creation. When he tried to publish his findings, the data vanished from his cloud storage overnight. Backup drives corrupted. Emails bounced. He laughed at first, assuming it was a coincidence, until his internet connection was cut for the first time in months. That was when he realized someone or something didn't want this spreading. Back in Cambridge, Lila began receiving anonymous emails. No sender, no subject lines, just attachments. Raw data files showing high-frequency waveforms, each one time-stamped precisely during the blackout period. She compared them with her own logs. The matches were flawless. The files contained readings from at least 4 different observatories, data that should have been classified. Whoever sent them had access beyond any public scientist. When she played the waveform as an audio signal, it wasn't noise. It was a low, throbbing pulse, steady, deliberate, eerily organic. She turned up the volume, closed her eyes, and for a moment, it felt as if she could hear a heartbeat from across the solar system. Slow, rhythmic, patient. There's a strange thing that happens when you listen to something that feels alive. Your brain starts assigning meaning, even if none exists. But this was different. The pattern was too precise, too balanced. It reminded her of a slow sonar sweep, something mapping its surroundings. She reached out to a contact at the European Space Agency. The reply came 12 hours later. "We can't discuss Atlas data over unsecured channels." That was the last she heard from him. Meanwhile, online discussion boards that had once buzzed with excitement were going silent. Posts were removed faster than they could be shared. A few users began migrating to private servers, using encryption and aliases to keep their conversations alive. Within those hidden corners of the internet, they began piecing together fragments of truth. One user, claiming to be a technician from a ground station in Alaska, uploaded a partial telemetry log. It described signal interference resembling directed energy, originating near the coordinates of Atlas's last known trajectory. The technician said the pattern repeated every 42 minutes, then abruptly stopped. He ended his post with a chilling line. "It felt like something stopped transmitting because it knew we were listening." The message spread through the encrypted chats like wildfire. It wasn't proof, but it was something. For every skeptic who demanded evidence, there were 10 more who felt deep down that something extraordinary was unfolding, just beyond the reach of public eyes. That night, Lila recorded a voice note to herself. Her voice trembled as she spoke. "March 17th, 0146 UTC, the signal is gone again. But I can't shake the feeling that it isn't random. It stops the moment attention peaks, like it's aware of being watched. I've never said this before, but for the first time, I think we might not be alone in this observation." She stopped the recording there, sat in silence, and let the weight of that thought sink in. The hum of her computer faded. The room felt colder. When the blackout finally ended on March 18th, space agencies around the world resumed their data feeds as if nothing had happened. The official statements framed the event as routine downtime, necessary calibration, technical coincidence. But anyone who had been following Atlas closely knew it was anything but ordinary. The first new image released showed a calm, diffuse comet tail, unremarkable, almost lifeless. But those who compared it with pre-blackout images noticed subtle differences. The structure of the tail had changed. The glow was softer but layered, as though faint trails of dust had rearranged into parallel lines. To the untrained eye, it was nothing. But to those who had been decoding the flickers, the lines seemed deliberate. Lila zoomed into the image until individual pixels blurred into haze. She tilted her head, squinting, until a familiar rhythm seemed to emerge from the arrangement of light and shadow. 3 lines close together, 2 spaced apart. 3 again, 2 again. A visual echo of the same pulse pattern, the one she had been hearing in the data. The pattern was back. Only now it wasn't flickering. It was woven into the comet's structure itself. Some called it coincidence, others called it proof. But none could deny that something intelligent, or at least something reactive, was embedded within Atlas's movement. By the time the next news cycle began, public interest had already shifted elsewhere. A new exoplanet discovery, a minor solar flare. The world moved on, as it always does. But in quiet observatories, dim basements, and sleepless offices across the globe, a handful of people couldn't let go. They stared at the same object, whispering to themselves the same impossible thought. What if Atlas wasn't a comet at all? Lila didn't tell anyone about her discovery for several days. She would sit in her office long after midnight, lights off, staring at that one high-resolution frame. The rest of the world had moved on, but she hadn't. The faint parallel lines in the comet's tail haunted her. They weren't perfect, but they were too evenly spaced to be random. When she inverted the contrast, the image looked like a message carved into light, simple, patient, and waiting to be understood. Outside, Cambridge slept under a thin fog. A clock tower struck 2, its echo soft against the old stone buildings. Lila leaned back in her chair, eyes closed. The hum of the servers filled the room, steady as breath. For the first time in her career, data felt alive to her. Not just numbers on a screen, but a pulse reaching across the void. In the following nights, more reports trickled in from amateur astronomers. A man in Chile claimed his telescope's tracking motor began moving on its own during an Atlas observation window. A group of students in Canada reported electromagnetic interference whenever they aimed their antenna arrays toward the comet. Most of these incidents were dismissed as equipment errors, but together they painted a strange picture. The closer one looked at Atlas, the more the universe seemed to look back. Somewhere deep in the archives of the European Space Agency, hidden beneath encrypted layers, was a file labeled simply Atlas Pulse Log. No one admitted to creating it, but those who found references to it said it contained recordings of low-frequency oscillations captured during the blackout. The oscillations had one curious property. They accelerated when the comet was observed and slowed when it wasn't, as though observation itself affected its rhythm. It was an idea both absurd and fascinating, a celestial object responding to human awareness. Quantum theory on a cosmic scale. By the end of March, whispers of an internal investigation began circulating. Several observatory technicians were reportedly questioned about data leaks. One of them, according to an unverified post on a private forum, claimed that their servers had recorded something impossible during the blackout, an outgoing signal, not from Earth, but to Earth it lasted only 3 seconds. A narrowband transmission of unknown origin, carrying no discernible information, but its frequency matched the same wavelength used in deep space radar experiments decades ago, the very frequencies humanity once used to send greetings into the stars. If true, it meant something, somewhere, had responded. Lila began to wonder if the blackout hadn't been about concealment at all, but about containment. Maybe someone somewhere had realized what was happening and decided the world wasn't ready to know. She tried reaching her old colleagues again, no response. Their phones went straight to voicemail. Her ESA contact's office line had been disconnected. She started writing everything down by hand. Dates, times, observations. A physical record that no one could delete. Each page filled with fine graphite lines, patterns, symbols, equations mixed with thoughts written in the margins, questions that sounded more like confessions. What is consciousness to a comet? Can observation be dialogue? If we are being studied, how long have they been watching? The more she wrote, the more she felt it, that subtle pull of curiosity that borders on obsession. Every night she'd step outside, breathe the cold air and tilt her head toward the dark, wondering if Atlas was still pulsing somewhere beyond Mars. And then, one early morning, her radio receiver crackled to life. It wasn't a strong signal, just a faint modulation buried beneath atmospheric noise. But the pattern was familiar. Long, short, short, long, the same rhythm that had vanished after March 18th. She froze, headphones pressed tight against her ears. The sound repeated every 42 minutes, growing slightly stronger with each cycle, as though the source was moving closer. Her pulse quickened. She opened the live orbital tracker. Atlas was currently near the asteroid belt, far beyond the range for any direct radio reception. Yet the signal was there, steady and calm, like a whisper through static. She recorded it, time-stamped it, then sat back in silence. The hum filled the room again, but this time it wasn't her servers. It was the sky itself, humming through the wires. For the next several hours she listened, watching as the waveform danced across her screen. At one point, she thought she heard modulation, tiny fluctuations in pitch that almost resembled speech, but too slow to recognize. She slowed the playback, and the tones stretched into drawn-out pulses, smooth and haunting, like the breath of a sleeping giant. She tried transmitting a reply. Nothing complex, just a simple binary ping. On the second attempt, the signal faded completely. The room fell silent. She waited for hours, but it never returned. That was the moment she understood. Whatever Atlas was, it didn't want conversation. It wanted acknowledgement. Say a nod across the endless dark. By the end of the week, she received another anonymous message. This time it contained a single line of text. Do not transmit again. It hears. No signature. No traceable address. The message deleted itself seconds after being read. Lila unplugged her receiver that night. She didn't sleep. Every noise outside made her heart race. The hum of passing cars, the faint whistle of wind under the eaves. The world suddenly felt different. Not empty but occupied. Watched. Days turned into weeks. The story faded from headlines. Scientists moved on to new discoveries, but every few nights small anomalies appeared again. Tiny fluctuations in deep space telemetry, unexplained distortions in radar returns. They came and went without pattern, but always around the same 42-minute cycle. Those who noticed began calling it the heartbeat of Atlas. The phrase caught on among late-night listeners, the kind who sat awake with headphones, searching the cosmos for meaning. They played the recorded pulses on loop, slowed them down, reversed them, layered them with ambient sounds. What emerged was something almost melodic, a deep, resonant rhythm that seemed to echo through the subconscious. And somewhere, beneath the noise, there was a feeling. A quiet recognition, as if the pulse wasn't coming from out there at all, but from inside the very thing that was listening. Months later, when Atlas drifted beyond the range of observation, the signals stopped entirely. The comet faded from radar, lost in the black between planets. The agencies issued their final report, a dry document filled with measurements, coordinates, and references to optical anomalies. Nowhere did it mention the flickers, the patterns, or the pulse. For the world, it became just another forgotten object passing through the solar system. But for a few who had watched too closely, it left a kind of silence that never quite went away. Lila kept her telescope, though she rarely used it anymore. Sometimes she'd sit beside it, sipping tea, eyes fixed on the blank night sky. The stars looked the same, cold and distant. But every now and then she thought she could still feel it, that faint rhythm under everything, like a heartbeat echoing through space. Not a message. Not a warning. Just a reminder that somewhere out there, in the dark between worlds, something once looked back and maybe, just maybe, it still does. NASA's Deep Space Network, a web of massive radio antennas scattered across the Earth, had always been humanity's voice into the cosmic void. It had spoken to spacecraft billions of miles away, heard the whispers of dying stars, and listened to the echoes of planets long gone cold. But now, as it focused on 3i Atlas, something unprecedented began to unfold. Every radar pulse sent toward the mysterious object came back wrong, distorted, fragmented, and rearranged in ways that defied ordinary explanation. It was as if the signal had entered a labyrinth of invisible geometry before returning, carrying with it a signature that felt eerily intentional. At first, engineers blamed equipment malfunction. They ran diagnostic sweeps through every circuit and frequency band, recalibrated antennas, and even replaced software modules to rule out interference. Yet the distortion persisted, consistent, rhythmic, and complex. The most unnerving detail wasn't the noise itself, but the patterns hidden within it. When analysts slowed the recordings down and mapped the frequency shifts across time, they discovered sequences of mathematical constants emerging and repeating. Pi, the golden ratio, woven into the very static of the return. These weren't the byproducts of chaos or chance. They were structures, and they seemed to evolve with each new transmission. Inside mission control, silence often followed each received ping. The room full of monitors, usually humming with casual chatter and quiet excitement, became a temple of unease. Screens flickered with the glowing trails of decoded data as algorithms struggled to make sense of the shifting waves. Some staff swore the patterns resembled modulation schemes, like those used in digital communications. Others thought the system might be picking up echoes from a natural plasma field interacting with solar radiation. Yet deep down, everyone knew that what they were witnessing didn't belong to the realm of ordinary astrophysics. Something about it felt aware. Weeks passed and the phenomenon intensified. Each radar pulse seemed to provoke a more complex response from the comet. The feedback loops grew richer, denser and harder to decrypt. One day, an analyst at the Jet Propulsion Laboratory noticed that if they sent a pulse at a specific timing interval, the returning distortion would mirror that interval precisely, but inverted. That discovery sent ripples through the scientific community. It was as though the object was listening, measuring, and intentionally responding to what was sent toward it. By the fifth week, a special task group was quietly formed between NASA, the European Space Agency, and the National Radio Astronomy Observatory. Their mission: to analyze the mathematical structures embedded in the return signals. To the public, 3I Atlas was still being labeled a high-interest comet with anomalous properties. Behind closed doors, however, the tone shifted dramatically. Private memos referenced non-gravitational intelligence signatures. Meetings extended deep into the night, filled with whiteboards scrawled with equations and cryptic waveforms. Some scientists were convinced that the repeating constants represented a universal mathematical language, a message written not in words, but in logic itself. As speculation grew, so did fear. The military became increasingly involved, demanding classified access to all transmission data. Officially, they claimed the goal was to prevent data leaks that might cause public confusion. Unofficially, whispers spread that defense networks were exploring whether the signals could be interpreted as tactical code, or worse, as a kind of surveillance system operating from deep space. To the engineers working late nights under flickering fluorescent lights, the line between science and science fiction began to blur. The distortion wasn't just sound, it had a presence. Each time the radar sweep touched the comet, it felt as though something immense and patient stirred on the other end, something not alive in any biological sense, but undeniably aware. When scientists plotted the waveforms into three-dimensional models, they noticed they weren't random shapes. The distortions formed spiraling lattices that expanded and contracted like breathing organisms made of energy. One researcher described it as watching a thought take shape in mathematics. Theories proliferated. Some proposed that 3I Atlas was encased in a naturally forming electromagnetic cocoon that reacted dynamically to solar wind, amplifying and reshaping external signals. Others whispered that it was a construct, an interstellar probe far older than humanity, perhaps damaged, attempting to communicate through the only language it still remembered: numbers. Late one night in the quiet of a data lab, an engineer noticed something subtle. When the return signals were stacked sequentially, a faint oscillation emerged, a pattern that, when translated into sound, pulsed with haunting regularity. The intervals matched the rotational period of the object almost perfectly. To the human ear, it sounded less like noise and more like rhythm, steady, deliberate, like the slow heartbeat of something that had traveled too far and for too long through the dark. The next morning, that same engineer played the audio for a senior scientist. They both listened in silence as the soft, rhythmic pulse echoed through the speakers. "Could it be alive?" the engineer asked half-jokingly. The scientist didn't answer. He just stared at the screen, the data streaming endlessly across it, his expression unreadable. In that moment, the room felt small, as though the walls themselves were listening. By the time dawn touched the horizon outside, the decision was made to suspend direct radar contact. Officially, the statement read, "Signal integrity compromised, further observation pending instrument recalibration." But among those who knew the truth, the decision carried another meaning entirely. They had spoken enough, and whatever 3I Atlas was, it had already spoken back. Days later, amateur astronomers continued to monitor the comet visually, unaware of the deeper mystery unfolding behind closed doors. The object glowed faintly red under the cold light of Mars, its tail shimmering like a thin thread of glass trailing into infinity. And somewhere within that light, hidden among the numbers, was something waiting, listening, still sending back its answers, one distorted echo at a time. As 3I Atlas approached the orbit of Mars, space itself seemed to hold its breath. Telescopes across the world tracked the comet's faint, ghost-like shimmer as it glided through the velvet dark, a pale wanderer that had already shattered too many rules to be ignored. Astronomers expected a quiet passage, perhaps another strange flicker, a pulse, maybe even a slight shift in trajectory. But what happened next would become one of the most debated moments in the history of interplanetary observation. At 03:12, Coordinated Universal Time, an unregistered surge of light erupted near Mars. It was silent. No sound could travel through the void, but its brilliance was unmistakable. The entire night side of Mars flashed for less than 2 seconds, enough for orbiting satellites to catch the reflection in their sensors. The illumination didn't resemble any known natural event. It wasn't a meteor strike, not a flare, not even a volcanic discharge. It was too symmetrical, too perfectly timed with 3I Atlas's passing arc. On the Martian surface, the Perseverance rover's instruments went haywire. Radiation detectors overloaded instantly. Temperature sensors spiked and the rover's navigation feed cut to static for 11 full minutes. When systems finally rebooted, engineers on Earth scrambled to understand what had just occurred. The radiation profile captured by Perseverance was unlike any known solar or cosmic signature. It contained periodic bursts of energy, repeating in intervals of exactly 141 seconds, an echo of the mathematical constant pi, the same number hidden within the radar distortions that NASA had previously received from the Comet. In the control rooms back on Earth, teams worked frantically, comparing readings from Mars orbiters, the Deep Space Network, and the James Webb Space Telescope. The data alignment was too precise to dismiss as coincidence. Roughly 37 minutes after the Martian flash, instruments across Earth began to detect faint magnetic fluctuations, tiny tremors rippling through the planet's protective field. They were small enough to escape general notice, but synchronized perfectly with the event near Mars. It was as though the entire solar system had briefly resonated in harmony with whatever had awakened inside that comet. The first reaction among officials was disbelief. Some labeled it a data correlation error. Others suggested a delayed solar flare, even though no corresponding activity was recorded from the sun. The timing was too clean, too artificial. The phrase energy synchronization appeared in several internal memos, always followed by cautious footnotes and redacted explanations. Outside those closed rooms, the world continued as normal, unaware that something across millions of miles had just blinked, and Earth had felt it. In the hours following the event, amateur radio operators around the world began reporting faint, rhythmic interference across multiple bands. The pulses came in at steady intervals, soft, mechanical, and eerily similar to the distortions NASA had detected weeks before. At first, the signals were dismissed as solar noise or atmospheric disturbance, but when recordings were compared across different continents, they matched perfectly. It was the same signature, the same hidden rhythm that had started with the Comet. Meanwhile, the Perseverance rover's onboard cameras, once systems were restored, revealed something else, something subtle but deeply unsettling. A thin, faintly luminescent haze lingered over the Martian horizon, visible only in infrared. It stretched upward like an invisible current, fading after several hours. Spectral analysis later revealed traces of unknown ionized particles, ones that didn't match any known Martian atmospheric component. They seemed foreign, perhaps interstellar in origin. It was as if 3I Atlas had exhaled, a breath of something ancient, electric and alive. Back on Earth, within NASA's Jet Propulsion Laboratory, sleepless scientists pored over the new data. One researcher proposed that the energy surge wasn't an explosion or a discharge, but a controlled activation. The comet, he suggested, might be harboring some kind of dormant mechanism, something triggered by its proximity to Mars's magnetic field. The idea sounded absurd, yet the numbers didn't lie. The emitted radiation wasn't chaotic, it was patterned. The pulse frequencies descended in a perfect harmonic ratio, 3:1. Nature rarely constructs such clean numerical alignments without cause. Over the following days, observatories across the world focused their instruments on the comet's path. They expected residual energy or perhaps thermal decay, but 3I Atlas remained calm, eerily calm. It glided onward, trailing a thin tail that shimmered in alternating hues of green and violet, faintly iridescent under solar light. The strange glow along its surface pulsed in intervals that matched the electromagnetic spikes detected earlier. It wasn't just moving, it was signaling. Within classified communication threads between NASA and the European Space Agency, a few analysts began to draw comparisons between the energy readings and the kind observed in theoretical propulsion systems, those based on magnetic field manipulation and quantum resonance. It was a fringe idea, bordering on science fiction, but the similarities were impossible to ignore. Some even speculated that the comet's strange maneuvers, those near-impossible course corrections earlier in its journey, were driven by the same kind of energy, controlled bursts, not random outgassing. As news of the anomaly began to leak through independent astronomy forums, social media filled with speculation. Some called it a natural phenomenon, others a hidden experiment, and a growing minority suggested something far more extraordinary, a technological presence disguised as a comet. While official agencies released carefully worded statements denying any abnormal extraterrestrial activity, their silence on specific data only deepened public curiosity. In the following week, the energy surge continued to echo faintly through the solar system. Instruments on the Lunar Reconnaissance Orbiter detected minute electrical disturbances in the Moon's shadowed craters, subtle but measurable. Meanwhile, Earth's auroras intensified unexpectedly, blooming in regions far beyond the poles. To those who knew what to look for, it was clear that something had connected everything. A single pulse that had stretched from Mars to Earth, like a whisper moving through invisible threads of energy. Then, just as suddenly as it began, the activity ceased. The comet dimmed, its pulse fading into the cosmic background. Mars's sensors stabilized, the magnetosphere calmed, but in every observatory, in every data archive where the readings were stored, the event left its scar, a moment where an object from another star had not just passed by but interacted. And deep in the heart of NASA's secure data vaults, among encrypted logs and redacted reports, one unexplained anomaly remained. Embedded within the radiation data was a faint signal, not noise, not random static, but a structured pattern, repeating in binary. When decoded, it revealed a simple numerical phrase, 42,000. To most, it was meaningless. But to those who had studied the comet's strange rhythm, its pulses, its constants, it was unmistakable. It was the same interval that had appeared before, the same number linked to the mysterious heartbeat detected weeks earlier. It was as if 3I Atlas had spoken again, just once, in the language of the universe, energy, pattern, and silence, and then drifted on into the dark, leaving Mars bathed in the memory of a single impossible flash. When the story of 3I Atlas reached a point of global fascination, something unexpected happened, not from a telescope but from a forgotten archive. A PDF began circulating online, shared anonymously through astronomy forums and encrypted academic chat rooms. Its title was understated, almost scholarly: Correlation of Celestial Symbolism and Extraterrestrial Motion in Early Mesopotamian Records. But its contents sent quiet tremors through both the scientific and historical communities. The paper claimed to have found direct correlations between the mysterious pulse patterns emitted by 3D Atlas and markings found on ancient Sumerian star tablets dated over 5,000 years ago. At first glance, it sounded like another piece of fringe pseudo-archaeology, an internet myth designed to attach mysticism to modern science. But the paper wasn't poorly written. It was meticulous, filled with mathematical comparisons, frequency analyses, and linguistic references that suggested an author with both technical expertise and access to restricted data. No author's name appeared, only a timestamp. March 24, 2025, 0312 UTC, the exact time of the Mars energy surge. That synchronicity alone was enough to capture attention. In the weeks following its quiet appearance, linguists and historians from various universities downloaded and analyzed it. The document made one bold claim: that a set of celestial carvings on an unearthed Sumerian tablet, known as the Enlil Codex, mirrored the orbital path and harmonic frequency of 3I Atlas's rotations. The Enlil Codex had long been considered a record of ritual astronomy. primitive constellations tied to agricultural cycles. But this new interpretation suggested that one particular engraving, long thought to depict a returning god star, might actually represent a periodic visitor from the stars, one that traveled in precise geometric intervals matching the comet's oscillations. The academic world dismissed the idea instantly. Pattern coincidence, one Oxford archaeologist said on a live broadcast. Humans find meaning in randomness. It's called pareidolia. Yet behind closed doors, several researchers admitted that the alignments were difficult to ignore. The frequencies inscribed in cuneiform numerals on the tablet, numbers representing 7s and 42s in ancient, counting aligned disturbingly well with the signal patterns recorded from 3i Atlas. Meanwhile, in online forums frequented by amateur researchers, a different narrative began to emerge. Users overlaid digital scans of the Sumerian star maps onto the projected trajectory of 3i Atlas. The alignment wasn't perfect, but certain anchor points, the cross of Nibiru, the 7 watchers, the path of the stranger, fell precisely along the comet's plotted course through the inner solar system. These weren't the random arcs of stars. They were deliberate, forming what one poster called a cosmic itinerary. Journalists soon caught wind of the discussion, fueling a surge of curiosity. Mainstream news outlets mocked it as another ancient aliens theory, yet the online community persisted. A linguist from Istanbul quietly published a short blog post under a pseudonym, noting that a specific Sumerian word used to describe a celestial visitor, Anza, could be translated as either the shining traveler or the messenger that returns. She also noted that in some temple inscriptions, this same symbol was surrounded by a sequence of triangles, each triangle symbolizing movement through space or time. When the number of triangles was counted, they matched the number of pulses in 3i Atlas's electromagnetic signal. Coincidence, or something that had been remembered and recorded thousands of years ago, long before telescopes or satellites? As night fell across observatories, a new wave of researchers began to consider the unthinkable. What if 3i Atlas wasn't just a visitor, they asked, but a returning one? Could it be that ancient civilizations had once witnessed a similar event? A brilliant comet that passed too close, left too deep an impression, and was then mythologized as a divine messenger? After all, comets have always carried the weight of prophecy, fiery omens, heralds of change and symbols of awakening. To test the theory, a small team of astrophysicists and historians collaborated unofficially, calling themselves the Anza Group. Using both ancient sky charts and modern simulation software, they attempted to backtrack 3i Atlas's trajectory across millennia. Their goal was to determine if it could have passed Earth's neighborhood before. The data was messy, incomplete, but one reconstruction startled them all. Roughly 5,200 years ago, around the very period when the earliest Sumerian tablets were inscribed, the comet's projected path intersected Earth's orbit. Not precisely, but close enough to be visible in the ancient sky as a dazzling, slow-moving anomaly. In one entry from that same era, written in wedge-shaped cuneiform, an astronomer priest described a burning star that stopped and breathed above the red planet. The text, long thought to be poetic exaggeration, suddenly took on new weight. It matched 3i Atlas's recent behavior near Mars almost exactly. The energy surge, the pause, the strange flicker of power. Skeptics, of course, dismissed the entire narrative. They argued that ancient observers often exaggerated celestial events, and that aligning myth with modern science was dangerous territory. But those who had seen the comet's recent data couldn't shake the resemblance. It was too detailed, too eerie. There was even mention in one clay tablet of a signal from the fire, written in symbols that resembled repeating waves, an echo of the rhythmic pulses recorded in 2025. As weeks passed, more connections surfaced. At the University of Chicago's Oriental Institute, a researcher uncovered an untranslated fragment describing the traveler that hums between worlds. The script's translation had been debated for decades, but under new light, the humming seemed to suggest a recurring resonance, perhaps electromagnetic, perhaps something else entirely. In a dimly lit archive room, a graduate student ran spectral analysis on photographs of the tablet, converting its patterns into sound frequencies. The result was haunting. A low rhythmic vibration, cycling every 42 seconds, the same number that had haunted every interaction with 3i Atlas since its discovery. Across digital communities, the term echo theory began to take hold, the idea that 3i Atlas was not a new visitor, but a returning signal, one that humanity had already encountered in the deep past. If true, it would suggest an intelligence or design older than recorded history. NASA refused to comment. The European Space Agency issued a curt statement emphasizing that no known celestial object exhibits intentional communication behavior. Yet, as more data leaked and more symbols aligned, silence became the loudest response of all. In a quiet corner of the internet, someone uploaded an enhanced overlay of the comet's trajectory over the Sumerian sky map. At the center, where the ancient map marked the Eye of Enlil, the comet's path intersected perfectly. The coordinates, when converted into modern celestial data, corresponded to the point near Mars where the energy surge had first been detected. Perhaps it was nothing more than a coincidence born of human pattern-seeking. Or perhaps it was what one anonymous researcher described in the final paragraph of that unverified paper: the universe may not forget. It records in light and memory the passing of travelers, ancient and returning. We are not discovering 3i Atlas, we are remembering it, and somewhere, millions of miles away, the comet continued its silent journey, unbothered by the noise of human wonder, moving steadily through the darkness, as though retracing a path it had once known by heart. The world was quietly shifting beneath the weight of an unseen visitor. While most eyes remained fixed on the familiar constellations and the daily rhythms of Earth, a select few had begun to notice something strange, something insistent. 3i Atlas was no longer just a comet drifting through the void. It had become a catalyst, stirring reactions that humans had neither anticipated nor fully understood. Its silent, pulsing presence elicited responses that ranged from meticulous observation to whispered speculation, from bureaucratic caution to outright fascination. In the hallways of government agencies, the conversations were measured, almost surgical. Intelligence briefings, usually reserved for terrestrial threats, now included trajectories, energy readings, and anomalous pulse patterns. A quiet directive had gone out to several nations' space defense networks: monitor Atlas continuously. No alarms were to be raised publicly. No official threat assessment was declared. Yet behind closed doors, engineers and military analysts worked long hours, poring over calculations, running simulations, and cross-referencing historical cometary data with the recent disturbances. Every variable was considered, every potential hazard weighed. But there was a tension, an unspoken acknowledgement that what they were witnessing might lie beyond conventional defense paradigms. Meanwhile, private space companies, sensing the growing intrigue, began to track the comet independently. Their press releases were carefully worded, vague and intentionally opaque. Object reclassification became the euphemism du jour, repeated in cautious statements from orbital tracking firms and satellite operators. The phrasing was deliberate, hinting at something extraordinary without revealing the full extent. Behind the corporate veil, engineers deployed high-resolution imaging satellites and spectrum analyzers, eager to witness phenomena that government instruments either could not access or were forbidden to disclose. Data collected in these private corridors of observation suggested an eerie consistency. The comet's luminosity was increasing, faintly at first, then perceptibly, as if drawing energy from a source unseen to human instruments online. The quiet hum of curiosity erupted into a cacophony. Conspiracy forums and amateur astronomer boards filled with speculation that oscillated between incredulity and obsession. Some insisted Atlas was an alien probe, its movements and pulsing signals evidence of an intelligence far beyond human comprehension. Others posited a cosmic AI, an autonomous entity traversing the interstellar medium, interacting with planetary bodies in ways too subtle to notice until it was far too late. Images taken by both professional and amateur telescopes were shared, enhanced and scrutinized, with every flare, every unexpected shift in brightness dissected for meaning. Users developed intricate models, attempting to correlate Earth-based observations with ancient star charts, lunar surface anomalies, and even magnetic field perturbations. Across the globe, responses varied. In the United States, analysts in NASA's mission control rooms exchanged quiet murmurs as they studied the rhythmic energy surges. In Europe, the European Space Agency convened emergency workshops to discuss potential international collaboration. East Asia saw private observatories mounting late-night campaigns, aiming telescopes not just for observation, but for continuous monitoring of every nuance of Atlas's tail. The atmosphere was electric, tempered by a soft, pervasive anxiety. Humanity was collectively holding its breath. Within this growing web of observation, a pattern began to emerge. Atlas's luminosity, though faint in the optical range, fluctuated in concert with its electromagnetic pulse cycles. Some researchers speculated it was feeding on solar wind particles, or perhaps interacting with the magnetic fields of nearby planets, subtly harvesting energy. Others suggested a far more radical hypothesis, that the comet might be absorbing the ambient energy of the solar system itself, quietly augmenting its mass or internal processes. While no evidence could confirm such a mechanism, the consistency of observed phenomena forced scientists to admit one uncomfortable truth: the comet's behavior was deliberate. This perception of deliberateness rippled into human psychology. Observers reported a strange compulsion to track Atlas continually, even those not professionally obligated. Emails flew at odd hours, chat forums lit up in the dead of night, and live feeds of the comet's trajectory were watched as though anticipating an emergent pattern, a signal, a message. Those who studied the data noted a shared sensation, a slow, creeping fascination, a quiet thrill intermingled with fear, as though Atlas itself had reached out across millions of miles and touched the curiosity of every human being, attuned to its presence. In governmental circles, the ripple effect of this fascination was not unnoticed. Strategists debated the potential implications of an object whose behavior seemed to skirt the laws of physics and challenge assumptions about interstellar phenomena. Contingency plans were drafted, ranging from observation-only protocols to theoretical intercept missions. None were likely to be executed, but the act of planning was itself a response, a recognition that Atlas, though silent, was now entwined with humanity's collective consciousness. Meanwhile, private companies unrestrained by protocol began to experiment. High-energy lasers, intended for calibration and tracking, were directed toward the comet at carefully calculated intervals. Observers noted subtle reflections, tiny deviations in its tail structure, and minute oscillations in light intensity following these pulses. No direct contact occurred, but the pattern was unmistakable. Atlas appeared to respond, not with speed or movement, but with modulation of its luminosity, a deliberate echo of human action. Public perception, meanwhile, vacillated wildly. Social media accounts amplified sightings, mathematical models, and even the faintest speculation. Hashtags began to circulate: Reese Comet Watcher, Reese Atlas Pulse, Reese Cosmic Messenger. Enthusiasts created simulations, overlaying the comet's trajectory with planetary positions, showing subtle alignments that coincided with observed surges. Theories ranged from benign, space debris with anomalous electromagnetic properties, to the fantastical, a sentient artifact from an ancient civilization, traversing the stars on a course that had long been predicted by now-forgotten stargazers. Amidst the excitement, a quieter, more reflective response emerged from certain corners of the scientific community. Physicists and mathematicians began to catalogue every subtle interaction, every rhythmic oscillation, and every micro-luminosity variation. They discussed entropy, resonance, and potential energy transfer mechanisms, but always with a cautious acknowledgement of the unknown. One researcher described it in a private note as listening to the universe think, an idea that captured both the beauty and the danger of what was unfolding. Even the media struggled to frame the story without veering into sensationalism. Early reports were filled with cautious language: anomalous comet activity, unexplained energy surges, extraordinary orbital patterns. Yet, beneath the surface, journalists could not ignore the extraordinary nature of the events. A subtle tension lingered. Humanity's gaze had been drawn to Atlas in a way that demanded interpretation, demanded reaction, demanded attention. In laboratories, Conference rooms and private living rooms alike, one realization began to settle in. The comet's growing luminosity suggested a capacity beyond passive existence. It wasn't merely a visitor. It seemed to thrive in the presence of observation, to draw in energy from its environment, and perhaps to communicate its awareness in ways humans were only beginning to perceive. Some likened it to watching the heartbeat of a distant, immense organism, a rhythm too slow, too deliberate to comprehend fully. As weeks passed, the comet's brightness increased incrementally. Even casual skywatchers could detect the subtle glow, now slightly more pronounced against the void of space. Amateur astronomers kept journals of the changes, noting fluctuations in intensity that seemed to follow no natural cycle. Patterns were reported across different hemispheres, different instruments, different observers, yet they were eerily consistent. Every measurement reinforced the growing consensus among those paying closest attention. Atlas was interacting with its environment in ways entirely unlike any known comet. In private communications, several space agencies acknowledged an emerging concern. If the comet were indeed responsive, if it could interact with electromagnetic fields and possibly energy sources on a planetary scale, what were its intentions? How much did it understand? Could humanity provoke unintended consequences simply by observing or measuring it? The questions were carefully posed, never officially published, but the weight of them hung heavy in every report. Even as governments tightened monitoring protocols and private firms continued their independent observations, the online community proliferated theories at an unprecedented rate. Mathematicians analyzed the pulse sequences, drawing fractals, primes, and geometric patterns. Coders created simulations to predict the comet's behavior, while philosophers and poets debated the ethics of observing a potentially conscious celestial entity. One online post captured the mood succinctly. "We are no longer just watching a comet. We are witnessing something that watches back." And yet, amidst all the meticulous study, the strategies, the conjecture, and the fascination, one truth remained stubbornly elusive. Nobody could claim to understand Atlas. Its movements, its luminosity, and its pulses defied simple explanation. Each hypothesis raised further questions. Each observation revealed deeper mysteries. Finally, one quiet night, as telescopes swept the skies and data streams illuminated countless monitors, Atlas performed a subtle, nearly imperceptible shift. Its luminosity flickered briefly, not dramatically, but enough to register across multiple observatories. Those watching held their breath, recognizing the rhythm, an almost deliberate modulation, a pulse that seemed to echo the very human attention it had been receiving for weeks. In that moment it became clear, humanity's response, with all its protocols, simulations, discussions, and theories had been noted. The comet was not merely a passive object in space. It was a participant in a silent dialogue, measured and deliberate, testing the limits of observation and understanding. And as the glow faded, leaving the night sky momentarily quiet once again, a question hung in the minds of all who had seen it. Were they merely observers, or had they become participants in a cosmic interplay older than human memory? A subtle conversation that spanned light years, millennia, and the deep pulsing unknown. The answer remained out of reach, hidden in the cold, silent trail of 3i Atlas as it drifted onward. Its growing luminosity a gentle reminder that it was aware, that it had been noticed, and that the story of humanity's response was only just beginning. A faint, unexpected flare along the comet's tail blinked once, a subtle signal that seemed to echo across the instruments, just enough to suggest that Atlas had a message to convey. And then, as quickly as it appeared, it vanished, leaving only the hum of anticipation and the soft, unbroken darkness of space. Humanity had acted. And in return, 3i Atlas had responded. The next chapter, unwritten and unseen, awaited. The universe, as always, was vast, silent, and indifferent, or so humanity had believed. Yet now, for those with instruments sharp enough to pierce the cosmic veil, there was a sound, faint but undeniable, threading through the fabric of space. It was not the hiss of distant stars, nor the static from ancient supernovae, nor the mechanical clatter of human-made satellites. It was something else entirely. A low, almost musical hum, subtle in its presence but unmistakably structured, It was as if the cosmos itself had leaned forward and whispered, coaxing humanity to listen. Radio telescopes across the globe, from the arid deserts of Australia to the frozen plains of Siberia, recorded the signal independently. Each station, using distinct arrays and calibration techniques, returned the same reading, a gently fluctuating frequency oscillating with a slow, deliberate rhythm. The hum was not chaotic. It rose and fell like a tide, modulating in intensity and pitch across a narrow band that had previously been dismissed as cosmic background noise. Analysts who had spent decades cataloging the constant chatter of the universe were stunned. There was pattern here, purpose, and a subtle intelligence woven through the sound itself. Audio engineers tasked with interpreting the mysterious signal were struck by its uniqueness. When converted into audible tones, it sounded less like noise and more like a form of communication. The waveforms resembled pulse-coded transmission, an organized repeating sequence that hinted at deliberate design. It was not music in the traditional sense, but it carried a rhythm so precise, so harmonious, that one could almost feel intention vibrating through the air. Each oscillation repeated every 72 hours, an interval too exact to dismiss as coincidence. Within observatories and research labs, scientists began to discuss the implications quietly, choosing words with care. It could be natural, one whispered, a resonant effect in the interstellar medium, amplified by the comet's energy field. Another countered, natural phenomena rarely exhibit temporal regularity like this. We may be listening to something, responding. The room fell into silence after that. To admit the possibility of deliberate signal, of an intelligible pattern echoing across the void, was to confront a profound shift in humanity's understanding of its place in the cosmos. The data was analyzed using techniques borrowed from communications engineering, astrophysics, and even linguistics. Spectrograms were generated, frequency-modulated patterns mapped, and timing intervals measured to millisecond precision. Every repetition, every subtle shift in amplitude, every slight inflection in tone was catalogued. Some researchers compared it to whale song, not for its sound but for its complexity. A structured, evolving pattern that carried meaning, a long-distance signal designed to travel through vast, empty spaces. As the weeks passed, the hum persisted. Occasionally, subtle variations appeared, small deviations in the pulse pattern that seemed almost improvisational. These deviations were never random. They were calculated, deliberate, as though a conscious entity were experimenting with rhythm, testing the observers, or perhaps attempting to guide human attention towards something deeper. For those analyzing the signal, the effect was hypnotic. One scientist, monitoring the waveform for hours in the dim glow of his office, described a sensation of being drawn into the hum itself, as if it were wrapping the mind in invisible threads of sound. Discussions moved beyond mere observation into speculation. Could this be a form of communication? Was 3i Atlas attempting to interact with humanity, using frequencies shaped by physics but designed for perception by sentient ears? Some suggested that the comet itself might be a carrier for an artificial construct, something ancient, interstellar, and aware, translating its presence into energy patterns detectable across light years. The hum was no longer just a signal. It became a bridge between human curiosity and the enigmatic intelligence of a traveler from the stars. In private communications between global observatories, scientists debated the ethics of responding. To emit a pulse back, to mimic or mirror the hum, could be a form of acknowledgement, a handshake across the void. Yet the risks were undefined, the consequences unknown. The signal could be harmless, a natural resonance amplified by the comet's energy fields, or it could be conscious, capable of reaction beyond human comprehension. To respond was to intervene. To remain silent was to observe. The weight of that decision hung over every discussion like a distant shadow. Meanwhile, hobbyist astronomers, radio enthusiasts, and small independent observatories joined the monitoring effort. They recorded their own data, overlaying patterns, comparing frequencies, and sharing their findings across encrypted networks. The growing network of listeners became an ad hoc collective, each participant aware that the comet's hum was changing the very way humanity paid attention to the cosmos. A subtle cultural shift began to emerge. Watching the night sky was no longer passive. It became an act of engagement, of listening, of participating in something larger than the self. Some engineers began experimenting with playback, sending faint harmonic echoes into space to see if the hum would respond. At first, nothing occurred, or so it seemed. Then, days later, a slight modulation was detected, subtle, almost imperceptible, but present enough to make even the most skeptical observers pause. The hum had shifted rhythm, adjusting in ways that suggested recognition. Analysts pored over the new data, measuring timing offsets, phase shifts, and amplitude variations. They wondered, was the comet learning, adapting, or simply reacting to environmental changes that coincided with their interventions? In control rooms and private labs, the signal became a meditation. Observers noted the calming effect of its rhythm, the hypnotic rise and fall of frequency that seemed to mimic the slow heartbeat of a massive, distant organism. There was beauty in its consistency, in the gentle undulation of sound that stretched across hours and even days. As humans listened, they found themselves immersed not just in data, but in a shared experience, a collective consciousness of curiosity, wonder, and the quiet thrill of encountering something utterly foreign. Amidst this calm fascination, debates persisted. Skeptics insisted on natural explanations, plasma oscillations, interactions with solar wind, or unknown quantum effects within the comet's core. Yet even the most skeptical engineers could not dismiss the recurring pattern of 72 hours. The precision, the subtle variations, the apparent responsiveness, it was uncanny. Some began to record these deviations meticulously, comparing them against Earth's own magnetic field, solar activity, and even the comet's trajectory. Slowly, a picture began to emerge. The hum was not just a background noise. It was structured, evolving, and possibly intentional. In universities, philosophy departments, and physics labs began to intersect in unusual ways. Scholars discussed the implications of listening to something so vast, so patient, and so persistent. Could this be considered language, or was it a form of mathematics, a universal code attempting to convey information beyond the limitations of human speech? Linguists suggested that repetition, timing, and subtle modulation might encode sequences, data, or instructions, much like early digital protocols. Mathematicians speculated on fractal patterns and recursive sequences, linking the hum to previous energy pulses detected from Atlas. One night, a small group of researchers convened in a dimly lit observatory. They placed speakers carefully around the room, converting the low-frequency waves into audible tones. The sound was mesmerizing. Gentle pulses that expanded and contracted, harmonics layered within harmonics, creating a sensation of immersion in space itself. Some described the experience as meditative, almost hypnotic. Others reported a strange intuition, a subtle sense of understanding, without knowing exactly what was understood. It was as though the comet was not merely sending a signal, but inviting humans into its rhythm, a quiet conversation conducted through the language of resonance. The broader public remained largely unaware of these developments, though subtle traces appeared in media reporting. Words like anomalous signals and low-frequency hum began appearing in cautious articles. Amateur astronomers posted recordings online, and the hum became something of a global secret, known to a small, growing network of listeners, yet invisible to the general populace. For those engaged, it was intoxicating, a slow revelation that suggested the universe might be capable of communication in ways never before imagined. As weeks turned into months, the rhythm of 72 hours persisted. Each cycle seemed slightly different, like a subtle variation on a theme, deliberate, patient, and mesmerizing. Observers began charting these cycles against solar activity, planetary alignments, and the comet's internal fluctuations, looking for triggers, correlating variables, and patterns within patterns. Every new observation seemed to deepen the mystery. The hum was constant yet flexible, structured yet evolving, simple yet impossibly complex. A quiet tension built around the question of response. To broadcast a signal in reply would be to assert humanity's presence, to engage directly with a force so alien that the consequences were unknowable. Scientists debated, engineers calculated, and ethicists pondered. Could an echo be interpreted as a threat, or as a greeting? The ethical weight of acknowledging something potentially conscious in the void weighed on every decision. The hum had become more than sound. It was now a mirror, reflecting humanity's curiosity, caution, and desire to understand. And then, one night, as a global network of observatories tuned into the hum, something subtle occurred. A single faint harmonic shifted unexpectedly, an imperceptible rise in pitch, a gentle undulation that had not appeared in previous cycles. It was not dramatic, but it was deliberate. The silence that followed felt charged, as though the universe itself had paused, waiting. Listeners across continents sensed the shift, some noting it in logs, others simply experiencing it. It was a whisper, a nudge, a reminder that something vast and patient was aware, and that humanity was now part of its attention. The comet's pulse, previously a distant hum, now carried weight. Each cycle of 72 hours became a meditation, a ritual of listening. For those attuned, the hum was a bridge to the cosmos, a gentle reminder of scale, mystery, and the persistent unknown. Yet even as fascination deepened, a quiet unease remained. Could humanity interpret the signal correctly, or was every pattern perceived merely a projection of desire, a reflection of hopes and fears cast onto the void? And as the faint harmonic settled back into its usual rhythm, those listening could not help but feel the enormity of the moment. Humanity had encountered a pulse from the stars, a frequency unlike any other, and for the first time realized that the universe might be capable of dialogue, subtle, measured, and infinitely patient. The next 72 hours approached like a silent countdown, and all who were listening waited. Somewhere out in the darkness, 3Y Atlas continued its slow journey, each hum a gentle reminder that while humans could observe, record, and speculate, the true nature of the comet's message remained just beyond comprehension. And then, at the precise midpoint of the cycle, a modulation occurred. A soft, deliberate oscillation that suggested recognition, an almost imperceptible response. It was not a word, not a signal in any conventional sense, but it carried intention, a presence, a quiet acknowledgement of the listeners. Humanity had heard it. And now the question lingered. Would they answer? The morning of April 9th, 2025, dawned quietly across Earth. A day that would later be remembered not for storms or political events, but for the subtle tremor of the cosmos, a turning point imperceptible to most, yet seismic for those watching the skies. Observatories from Chile to Hawaii, from the frozen expanse of Antarctica to the deserts of Arizona, had been trained on 3I Atlas for weeks, cataloging every fluctuation, every pulse, every modulation of its growing luminosity. Yet nothing in the data prepared them for the sudden, deliberate shift the comet would make that morning. Without warning, almost imperceptibly at first, Atlas altered its trajectory. It was a movement that defied known celestial mechanics, a subtle acceleration at first that quickly grew into something far beyond human expectation. The comet, previously drifting in a manner that suggested passive observation, now seemed purposeful, deliberate, and intent. Calculations confirmed what engineers and astronomers could scarcely believe. It was accelerating toward the outer solar system at a rate that no natural outgassing, no gravitational slingshot, no known propulsion could account for. The change was first detected by the European Space Agency's tracking arrays. Early morning logs showed a sudden deviation from predicted paths, a line on a screen that veered sharply, then stabilized along a new vector. Alerts cascaded through observatories worldwide. In the calm, fluorescent-lit control rooms, scientists murmured to themselves, verifying calculations over and over, seeking error in instrumentation, software, human oversight, but every verification confirmed the same impossibility. Atlas was moving with intention. As the acceleration continued, the comet left behind a thin, glowing, ionized trail. It was delicate, almost ephemeral, a gossamer thread stretching across the black canvas of space. Yet for those watching with sensitive imaging equipment, it was breathtaking. The trail shimmered in ultraviolet and X-ray spectra, a subtle but undeniable signal etched across the heavens. To the untrained eye, it would have appeared as nothing more than a fleeting aurora, a ribbon of light against the void. To those attuned, it was a cosmic signature, an announcement written not in words but in the very particles of matter itself. spectroscopic analysis revealed a revelation that stunned the scientific community. Within the ionized trail, patterns emerged, not random distributions of ions or dust particles, but structured molecular formations, repeating sequences of chemical arrangements that suggested intentionality. Carbon chains arranged in regular intervals, nitrogen clusters forming symmetric patterns, and oxygen atoms positioned with surprising precision. It was as though the comet had written a message in its wake, encoding information in chemistry itself. Initial reactions varied. Some astrophysicists speculated that the patterns were emergent phenomena, natural structures formed by solar-wind interactions, particle collisions, or magnetic field resonances. Yet repeated observations made these explanations increasingly implausible. The structures were too regular, too persistent, and too complex. Patterns emerged in multiple wavelengths, confirming that this was not an artifact of a single telescope, a single set of instruments, or a software glitch. The universe, it seemed, had become a laboratory, and Atlas was the experimenter. Private research groups, emboldened by the discovery, began coordinating simultaneous measurements across the globe. Teams in Japan, Russia, Brazil, and South Africa synchronized spectrographs, cross-referencing data to map the molecular formations in 3 dimensions. Weeks of painstaking observation revealed repeating motifs, variations on a theme, almost like sentences or stanzas in a chemical language. Some clusters hinted at repetition akin to syntax, sequences of atomic arrangements that suggested a message structured in layers, readable by those patient and attentive enough to parse it. The implications were staggering. Humanity had long searched the stars for evidence of intelligent life, for signs that the universe was not empty of consciousness. And now, for the first time, an object from interstellar space seemed to be attempting communication, but not in electromagnetic waves, radio pulses, or digital signals. Instead, in chemistry, encoded in the very material of its being. The idea was both thrilling and terrifying. An interstellar courier, sending messages across light years, using tools and methods humans were only beginning to understand. The comet's acceleration continued, subtle yet persistent. Analysts calculated that it would reach the Kuiper belt within months, its speed unmatchable by any spacecraft humanity had yet constructed. Tracking the comet became an obsessive exercise. Mathematicians modeled its movement, simulating every plausible trajectory, attempting to predict the evolution of its molecular messages. Each cycle revealed new patterns. Each observation revealed layers of complexity. Atlas had become not just an object to observe, but a phenomenon demanding interpretation, a puzzle encoded in both motion and matter. Global reactions varied. Governments, still cautious, maintained surveillance while issuing minimal statements. A few leaked reports noted that international space agencies had convened in emergency sessions to discuss contingency measures. The comet was no longer a passive traveler. It was active, and its activity was intelligible in ways humans had never encountered before. Yet public media remained largely muted, releasing carefully worded updates about unexplained cometary behavior and ongoing monitoring. The spectacle, the magnitude, the implications, all were intentionally subdued. Online, amateur astronomers, coders, and hobbyists became crucial collaborators. Data shared on forums, processed through open-source software, and visualized in innovative ways revealed subtleties invisible to institutional analysis. Some users developed chemical mapping algorithms, attempting to decode the message embedded in the ionized trail. Others created virtual simulations of the comet's molecular patterns, translating them into geometric shapes, sound, and even symbolic representations. The comet, through its trail, had become a teacher, a composer, a silent communicator, inviting the most curious minds to engage. There was an emerging sense of ritual among observers, at precise moments in its trajectory. When Atlas emitted new molecular formations, telescopes would align, spectrographs would record, and networks of listeners would track the comet's passage in quiet reverence. Humanity had collectively paused to witness a phenomenon far beyond comprehension. It was no longer about discovery alone. It was about presence, attention, and the slow hypnotic act of observing something deliberate and alien. Scientists noted subtle interactions between the comet's trail and the solar magnetic field. Plasma oscillations in Earth's vicinity fluctuated in harmony with the molecular patterns, suggesting that Atlas's influence extended far beyond visual or chemical observation. A faint, almost imperceptible electromagnetic resonance accompanied the chemical sequences, as though the comet's acceleration and its chemical message were intertwined. To those listening and watching, it became clear that Atlas was not a mere rock. It was a system, a vehicle of information, an interstellar composer using matter, energy, and motion to communicate. Ethical debates surfaced quietly among the scientific community. If the comet was communicating, if the message was deliberate, should humanity attempt a response? Some argued that decoding and responding would be a form of engagement, a handshake across space and time. Others warned of risk, of misinterpretation, of unforeseen consequences. The comet's trajectory, its acceleration, its chemical message, none of it could be fully understood in human terms. Yet to ignore it would be to forsake the opportunity to engage with a phenomenon unlike any before. As the comet's glow faded each night behind the solar glare, the molecular trail lingered in observations, a persistent signature of intention. Teams continued to map and analyze, noting recurring motifs that suggested continuity, a grammar underlying the chemical language. Every pass, every measurement deepened the mystery, inviting questions rather than providing answers. The comet had become a mentor of sorts, a teacher whose lessons were slow, patient, and delivered in the quiet language of the cosmos. Observers reported a strange emotional resonance. Sitting alone with screens and instruments, researchers felt a subtle connection to the distant traveler. It was not fear, not excitement, but a calm attentiveness, a meditative awareness of participating in a story that spanned light years, centuries, and the infinitesimal moments of human observation. Humanity was no longer merely studying Atlas. It was part of a dialogue, listening and watching, learning to understand in ways that went beyond conventional science. And then, as Atlas approached a particularly sparse region of the solar system, the comet performed another subtle maneuver. A small deviation in its path caused the molecular trail to form a lattice-like structure, more complex than any observed previously. It was as though the comet was emphasizing a point, a crescendo in its silent symphony. Spectrographs recorded intricate sequences, repeating across wavelengths, while computer models struggled to simulate the level of precision evident in the chemical patterns. In the quiet observatories, late at night, scientists whispered among themselves, could this be a form of interstellar instruction? Was the comet attempting to encode knowledge, mathematical, physical, perhaps even philosophical, in a medium as tangible as chemistry? The questions were unanswerable, yet irresistibly compelling. Observers felt the weight of the unknown pressing gently upon them, a reminder that the universe was not just to be catalogued, but to be experienced. As the final hours of April 9th unfolded, Atlas's acceleration slowed, its new trajectory stabilized, and the ionized trail continued to shimmer for days, a glowing testament to its passage. Humanity had witnessed something unprecedented, motion, matter, and message intertwined in a deliberate, intelligent pattern. The comet had accelerated, left a chemical signature, and in doing so, changed the very way humans perceived the cosmos. Yet, even as telescopes and spectrographs continued to record, a subtle tension remained. Was this the beginning of a larger message? Would Atlas continue to communicate, or had it merely marked this moment in its journey? The answers were as distant as the comet itself, stretching across millions of kilometers, waiting for humanity to continue listening. In that silence, one thought emerged across all those watching and recording. The turning point had arrived, not just in the comet's trajectory, but in humanity's awareness. The universe had whispered through matter, through chemistry, and for the first time, humans understood that listening might be the most important act of all, and somewhere, beyond the orbit of Neptune, 3i Atlas glided forward, leaving behind not just an ionized trail, but the faint, enduring pulse of a message waiting to be unraveled. The leak appeared quietly at first, as if it were testing the waters of human curiosity. Hidden within a small encrypted forum on the dark web, a classified European document made its way into the hands of a few determined observers. It was never intended for public eyes, but like all secrets, it eventually slipped through the cracks of containment. The document contained thermal scans of 3I Atlas's nucleus, captured during its recent passage through the inner solar system, and what it revealed immediately drew both awe and unease. Under infrared imaging, the comet's nucleus displayed patterns unlike anything typically observed. Natural comets formed from the chaotic accumulation of ice, dust, and rocky fragments over eons are irregular in shape, pockmarked, jagged, almost random in their contours. Yet Atlas appeared different. Its surface geometry reflected light in ways that suggested symmetry, almost deliberate in its precision. Triangular facets, near-perfect hexagonal patterns, and mirrored angles were apparent across multiple scans. At first glance, it seemed impossible. The universe rarely, if ever, crafted such order in an object that should have been messy and organic. The implications were immediate and unsettling. A few scientists whispered the possibility that Atlas might not be entirely natural, that it could be artificial, or perhaps an artifact of intelligence from somewhere far beyond the solar system. These were not casual musings. They were serious conjectures grounded in precise measurements and repeated observations. Each facet, each reflective plane suggested intentionality. Patterns repeated across scales, as though a designer had applied a blueprint rather than random processes. Yet the idea of labeling the comet artificial was not without controversy. Within the scientific community, the debate fractured quickly and decisively. One camp argued for caution, warning that human minds are wired to detect patterns, to project intention where none exists. Anthropocentric thinking, they insisted, was a dangerous trap. Just because a form seemed deliberate, symmetrical, or even intelligent, did not mean it was anything other than a cosmic coincidence, a quirk of thermodynamics or material stress. Science demanded skepticism, and skepticism demanded restraint. Meanwhile, the other camp, emboldened by the repeated symmetry, pushed further. They examined every thermal image, overlaying data from previous cometary observations, searching for analogues and finding none. They traced geometric alignments against the comet's trajectory, rotations, and orbital velocity, noting correlations too consistent to ignore. They spoke in quiet, urgent tones about evidence of design, non-natural structuring, and even potential functional geometry, hinting at the possibility that Atlas could be engineered, or at least manipulated by a process unlike any earthly physics they had yet encountered. The fracture widened into heated debate in journals, conferences, and private communications. Some senior astronomers called for discretion, warning that premature speculation could undermine decades of credibility. Yet younger researchers, more willing to entertain radical ideas, argued that the data could not be ignored. It was an unprecedented opportunity, they said, to confront the unknown in its most immediate and tangible form. And while no one claimed certainty, the tension was palpable. The universe had presented a puzzle that strained the limits of human understanding, and every interpretation carried both risk and wonder. In private labs, thermal scans were magnified, digitally enhanced, and run through algorithms designed to detect artificial constructs. The results were both compelling and confounding. Angular patterns seemed to repeat at different scales, suggesting fractal-like self-similarity, a property often associated with intentional design. Edges aligned almost perfectly along axes, defined by the comet's spin, reflecting sunlight in a way that seemed more calculated than accidental. Some physicists muttered under their breath about engineering signatures and technological fingerprints, though all couched their words with caution, aware of the profound implications of suggesting extraterrestrial intelligence. Discussions spilled into interdisciplinary realms. Mathematicians, computer scientists, and even architects were consulted to analyze the symmetry. Patterns within the nucleus were compared to known natural crystalline structures, to human-engineered forms, and to theoretical constructs for interstellar probes. Every comparison reinforced the strangeness. The nucleus did not fit neatly into either natural or artificial categories, existing in a liminal space that defied conventional classification. It was neither purely organic nor overtly manufactured, and yet it hinted unmistakably at coherence. Ethics, too, became a subject of debate. If Atlas were artificial, even partially, what responsibility did humanity have in interpreting it? Could the comet itself contain a message, a warning, or instructions? Were these geometric formations simply decorative, or were they functional, designed to interact with observation technologies in ways humans were only beginning to detect. The questions multiplied faster than the answers. Each one weighted with a strange combination of wonder and apprehension. The document also revealed another anomaly. The reflective symmetry persisted across thermal fluctuations. Comets naturally heat and cool unevenly, yet Atlas maintained its structural patterns despite rapid temperature changes. The surfaces adjusted with precise consistency, as though responding to environmental variables. For some, it was a whisper of awareness, a subtle form of agency encoded in matter. For others, it was an optical illusion magnified by advanced imaging techniques. The debate, intense and continuous, would define the next months of research. Observers on the ground began to notice subtle effects beyond imagery. Instruments tuned to measure electromagnetic emissions recorded fleeting anomalies around Atlas, transient pulses that seemed to correlate with its symmetrical patterns. While small, these pulses were consistent and repeated with each rotation, suggesting that the comet's structural features might influence its energy output. Was Atlas responding to the sun, the solar wind, or perhaps something more enigmatic? The notion seemed almost impossible, yet every data set pointed to interactions that were both intentional and measurable. Even amateur astronomers contributed to the unfolding story. Equipped with smaller personal telescopes, they tracked the comet visually and photometrically, noting reflections, angles, and brightness variations that mirrored the thermal symmetry. Some reported flashes that appeared patterned, fleeting alignments visible only for a fraction of a second. These observations, once dismissed as visual noise, began to fit into a larger picture. The more people observed, the more coherent the comet appeared to become, a subtle, quiet intelligence revealed in angles, reflections, and thermal resonance. The cultural impact, though muted at first, began to emerge. Blogs, forums, and informal networks of observers speculated in hushed tones, sharing enhanced images and calculated models. The comet, previously an object of passive observation, became almost a character in a narrative, an enigmatic traveler with secrets embedded in its very form. Poets and philosophers quietly joined the discussion, framing the patterns as potential symbols, a language in stone and ice, speaking across the emptiness of space in a medium humans had only begun to interpret. Yet caution persisted. Senior scientists warned constantly against leaping to conclusions. "Anthropomorphism is a seductive trap," one wrote in a private memo. "We see intent where none exists, symmetry where chaos rules. We must measure, observe, and calculate before we theorize." But even as these cautions were voiced, the data refused to be ignored. The patterns persisted, their repetition and precision undeniable. Humanity was faced with the delicate balance between skepticism and curiosity, between restraint and the lure of wonder. As April passed, further thermal scans deepened the mystery. Different wavelengths revealed additional geometric patterns, previously hidden beneath surface noise. Angular formations aligned along axes that hinted at rotational logic, energy channels, or even communication intent. Some physicists speculated that Atlas might have been shaped or reshaped over millions of years, either naturally or artificially, in ways designed to survive interstellar travel and remain coherent under the stresses of cosmic radiation. The comet had become an enigma, a silent educator, challenging every assumption humanity had made about the randomness of celestial bodies. Debates extended into secrecy and international tension. Governments and space agencies quietly coordinated to monitor the comet, wary of the potential geopolitical ramifications of a discovery that hinted at intelligence beyond Earth. A sense of quiet urgency settled over the scientific community. If Atlas truly contained signs of artificial origin, understanding them could redefine humanity's place in the cosmos. Yet revealing such a discovery prematurely could incite panic, skepticism, or worse, misguided attempts at intervention. At the heart of the debate, however, was the simple, profound recognition that humanity had never encountered anything like this. A lone interstellar visitor, silently traversing the solar system, had exposed anomalies that stretched comprehension, symmetry where chaos was expected, geometric logic where randomness should reign, and behavior that hinted at awareness or design. For observers, it was as if a door had opened, a glimpse into a cosmic library of possibilities, a reminder that the universe was far stranger and more deliberate than previously imagined. And so, as telescopes continued their vigil, thermal scanners humming softly, and observers around the globe whispered into data logs and personal journals, Tri-Atlas drifted onward, a quiet enigma in the vastness of space. Its patterns reflected light in precise angles, its energy signatures pulsed in subtle rhythms, and humanity, for the first time, realized that the line between natural and artificial might not be absolute. The universe had posed a question, and all anyone could do was listen carefully, observe meticulously, and wonder endlessly. The vastness of space has a way of humbling even the most seasoned explorers, a reminder that time and distance are measured not in days or hours, but in light years and eons. And yet on a quiet evening in April 2025, humanity experienced an anomaly that transcended both scale and expectation. For decades, Voyager 2 had drifted into interstellar space, carrying its golden records, its instruments long considered obsolete, its voice reduced to faint pings that barely grazed the edges of our detection capabilities. It was, for all intents and purposes, silent, until now. The first indication came from a small team of engineers monitoring deep space communications at NASA's Jet Propulsion Laboratory. Among stacks of telemetry data and routine error logs, a faint, irregular transmission appeared. It was subtle, almost imperceptible, a whisper in the cosmic noise. At first, the engineers assumed equipment malfunction, or perhaps interference from solar activity, a magnetic anomaly, or distant radio frequency echoes. Yet the signal persisted, pulsing with a rhythm that was neither chaotic nor random. Its frequency was structured, deliberate, and curiously familiar. As the data was passed, analysts noticed something extraordinary. Within the transmission were fragments of data recorded decades earlier, some originating as far back as 1989. Normally, Voyager's memory banks stored telemetry sequentially, yet these fragments had been rearranged in a pattern that seemed impossibly intentional. The sequence of signals echoed the pulse frequency observed from 3i Atlas, the same low-frequency hum that had captivated astronomers and enthusiasts alike. It was as if the Comet and the probe, separated by millions of kilometers and decades of spaceflight, were somehow in communication, or at the very least resonating in synchrony. Engineers were hesitant to voice their speculations. Voyager's systems, after all, were rudimentary by modern standards, designed for simple measurement and communication, not complex processing or synchronization with external phenomena. The immediate assumption was random interference, a quirk of aging electronics or cosmic background noise. Yet even the most skeptical among them could not dismiss the alignment of Voyager's newly rearranged data with Atlas's pulsations. The probability of coincidence was vanishingly small, a statistical anomaly bordering on impossibility. Word spread quietly through the halls of NASA. Senior scientists convened emergency briefings, projecting waveforms, spectrograms, and telemetry logs onto large screens. Every eye in the room lingered on the same puzzle. The old probe, long assumed dormant in practical terms, had emitted a pattern mirroring a signal from a newly arrived interstellar visitor. Questions multiplied faster than answers. Had Atlas somehow influenced Voyager remotely? Could an interstellar object generate a field or resonance capable of affecting decades-old electronics? Or was this merely a cosmic coincidence, a rare intersection of chance and observation? As discussions unfolded, mathematicians and physicists began modeling the phenomenon. They compared the time intervals, the phase shifts, the amplitude variations of Atlas's pulse with Voyager's transmission. The match was uncanny. Every 72-hour cycle of Atlas's hum corresponded to subtle modulations in the Voyager data. The variations, once interpreted as random, now appeared patterned, deliberate. For those studying the signals, the realization was intoxicating. An object from interstellar space might be capable not only of influencing its immediate surroundings, but of reaching across time and technology, awakening humanity's oldest messenger in the process. Outside the conference rooms, the news, or fragments of it, began seeping into specialized scientific forums and private networks. Amateur astronomers, radio enthusiasts, and coding hobbyists pored over shared Voyager datasets, overlaying them against Atlas's observed pulses. Together, They built digital maps of resonance, plotting the probe's weak emissions alongside the comet's ionized trail and low-frequency hum. Visualizations depicted a subtle dance, an interstellar choreography that hinted at intentionality, at a hidden intelligence guiding both celestial bodies and human-made artifacts in a synchronized rhythm. Yet, even as excitement spread, caution persisted. For every voice whispering about potential intelligence, another reminded colleagues of the dangers of interpretation. Voyager was a machine, after all. Its circuits simple, its sensors rudimentary, subject to cosmic radiation, aging components, and software decay. Could the apparent alignment be nothing more than the mind's tendency to detect order in chaos, to impose pattern where none truly existed? The debate split laboratories and conference calls, a subtle tension between skepticism and the irresistible allure of the impossible. Meanwhile, the public remained largely unaware. Media outlets released cautious statements about anomalous telemetry and unexpected deep space signals, but the gravity of the events was downplayed. Most people, unaware of the intimate choreography unfolding millions of kilometers away, continued their routines, oblivious to the whispers of connection between an ancient human probe and a comet from the stars. For those engaged in observation, however, every pulse was a revelation, each subtle shift a testament to the delicate interplay between the human-made and the cosmic. Engineers began to experiment carefully, attempting to send signals back to Voyager. The goal was not to command or manipulate, but simply to establish a form of dialogue, a test of responsiveness. Low-power pings were transmitted, coded to mimic Atlas's frequency patterns. For hours nothing happened, and the quiet hum of anticipation grew heavier. Then faintly Voyager responded, a subtle modulation echoing the sequence, repeating, almost acknowledging the presence of observers on Earth. It was a soft interaction, yet profound. Decades of human effort, now entwined with the comet's mysterious journey, had produced the first signs of resonance between a machine and the unknown. As the world's telescopes continued to track Atlas, engineers monitored Voyager with equal care. Every pulse, every rearrangement of data, every subtle shift in amplitude was recorded, catalogued, and analyzed. Simultaneously, amateur observers contributed to real-time analyses, their own equipment capturing nuances invisible to larger arrays. Together, humanity had created a network of observation, spanning continents and disciplines, focused entirely on listening, deciphering, and understanding. The philosophical implications were profound. Voyager had been humanity's first emissary beyond the planets, carrying messages intended for hypothetical civilizations in distant star systems. Now, decades later, it appeared that the cosmos might be responding, echoing back in resonance with an interstellar visitor. For the first time, the dream of communication across space and time seemed less abstract, more immediate and deeply personal. The universe, previously a silent witness, had begun to engage, even if only subtly. Conversations in private research forums began to speculate about consciousness and agency. Could Atlas, a comet of unknown origin, influence objects crafted by humans, coordinating patterns across millions of kilometers? Was the comet itself aware, capable of detecting human observation, or merely interacting with electronic systems in ways dictated by physics, yet uncharted? The questions were unanswerable, and that uncertainty only amplified fascination. Each observer felt a mixture of awe, fear, and humility, a recognition that humanity was small, yet in a sense connected to something unimaginably vast. As April wore on, the interplay between Atlas and Voyager continued. New data confirmed subtle changes in Voyager's readings, variations that aligned closely with shifts in the comet's trajectory, its pulse cycles, and even the chemical patterns observed in its ionized trail. Analysts began to hypothesize mechanisms: electromagnetic resonance, induced currents, subtle gravitational perturbations, but none could fully account for the precision and timing of the apparent interaction. The universe had presented a puzzle, and humanity was forced to listen carefully, to observe with patience, and to accept that the cosmos was capable of gestures far beyond conventional expectation. Observers described a unique sense of participation. Sitting alone at consoles or under the night sky with modest telescopes, they felt an intimate connection to both Voyager and Atlas. Each pulse was like a heartbeat, each modulation a quiet breath, a reminder of the delicate interplay of matter, energy, and observation. It was a meditation, a shared consciousness stretching across space and time, binding human curiosity to the motions of an object older than the Earth itself. And then, in one particularly quiet observation session, a subtle anomaly emerged. Voyager's transmission included a pattern that appeared intentionally modified, not merely mirroring Atlas's hum but introducing new variations. These deviations were small but unmistakable, suggesting a rudimentary form of reply rather than mere resonance. Analysts pored over the data for hours, running simulations, cross-referencing historical telemetry, and verifying instrumentation. The result was the same. The oldest human-made probe had become in some way responsive, participating in a dialogue humanity had never imagined. As the day ended, the comet drifted farther from Mars, Voyager continued its steady journey into the void, and humanity sat in quiet fascination. For the first time, there was a sense of engagement, of resonance, of connection, a reminder that even across the immense distances of space and the decades of human endeavor, communication might not be impossible. The universe had spoken subtly through Atlas and Voyager, and the whispers were impossible to ignore. The call from Voyager was more than a signal. It was a turning point. Humanity realized that observation alone was no longer sufficient. Listening, interpretation, patience, and openness to the unknown were required. The cosmos had invited a dialogue, one that demanded attention, humility, and awe. And as the final signals of the day were catalogued, observers could not help but feel a profound sense of participation in something far larger than themselves. A cosmic conversation that had begun with a hum, extended across decades, and now threaded together comet and probe, past and present. In a dance of mystery and quiet wonder, the void of space, though silent to human ears, is never truly empty. It holds particles, radiation, subtle gravitational fields, and the faintest echoes of light from stars long extinguished. And yet in April 2025, a new phenomenon appeared within that darkness, something that seemed to defy both expectation and explanation. 3I Atlas, already a source of fascination for its improbable trajectory and mysterious pulse, revealed yet another astonishing feature, a reflective structure forming along its surface, as though the comet itself were reshaping into something entirely new. Infrared scans captured the transformation first, the delicate glow of heat revealing patterns that could not be attributed to simple ice sublimation or natural mineral formation. The structure had a crystalline quality, intricate yet cohesive, forming across previously irregular terrain. It seemed almost organic in precision, bending and reflecting infrared light in patterns that were subtle, complex, and utterly deliberate. Unlike a natural comet, whose surfaces tend to be jagged and irregular due to erosion and outgassing, Atlas now presented surfaces that mirrored one another, a lattice of reflections that suggested purpose rather than randomness. Observers around the world were immediately captivated. From observatories in Chile, Japan, and Arizona, to private telescopes operated by dedicated enthusiasts, every imaging system detected faint holographic distortions emanating from the comet. The effect was subtle but unmistakable. Light passing over the crystalline surface appeared to refract and scatter in ways that created ephemeral, ghostly shapes in the surrounding void. These projections did not reflect the sun in the usual sense. They seemed to respond to the observer, subtly shifting as if aware of being watched. For a phenomenon previously classified as a simple comet, this behavior was unprecedented. Discussions within the scientific community were cautious, yet filled with excitement. Some theorized that solar radiation interacting with newly formed crystalline layers could produce transient optical phenomena, bending light in unexpected ways. Others suggested that the surface might be charged electrostatically, interacting with solar wind particles to produce faint plasma-like reflections. But as models grew more detailed, the results fell short of capturing the precision and complexity of the observations. The reflective patterns were not random. They were consistent, patterned, and almost intentional. Infrared spectrographs revealed additional subtleties. The crystalline membrane appeared to have a multi-layered structure, with each layer reflecting a slightly different spectrum of light. These layers interacted with one another, creating interference patterns reminiscent of holographic projections, though in three-dimensional space and on a scale incomprehensibly large. For researchers attempting to interpret the signals, it was as if Atlas had developed a surface capable of both communicating and observing, an interface between the comet's internal processes and the external universe. As imaging data streamed in nightly, analysts noticed something even more extraordinary. The reflective structure seemed to change orientation and curvature in response to its environment. Angles shifted in subtle increments, facets rotated slightly to capture and redirect light, and the holographic distortions appeared to pulse gently in synchronization with Atlas's previously recorded hum. For the first time, there was evidence that the comet was not only reflecting energy, but modulating it, almost as if it were experimenting with optical communication on a scale beyond comprehension. The idea that a comet could behave this way was nothing short of revolutionary. Natural comets, shaped by billions of years of collisions, erosion, and gravitational influence, were chaotic and unremarkable. Yet here was Atlas, not only defying Newtonian physics with its trajectory, but now manifesting a reflective structure that suggested control, coherence, and perhaps intention. The juxtaposition was mesmerizing. A seemingly simple object transforming into something far more complex, blurring the line between celestial body, machine, and message to ground-based observers were not left out of the experience. Amateur astronomers using infrared-capable telescopes captured faint, shifting glimmers that hinted at patterns, almost like ripples across a mirror's surface. Many described a sense of awareness, a subtle feeling that the comet was not only present in the sky, but interacting with those observing it. Forums and private networks buzzed with excitement, sharing enhanced images, animated reconstructions, and cross-referenced data sets. The phenomenon became a quiet, global meditation, an exercise in collective observation and shared wonder. Back in professional laboratories, engineers and physicists began creating simulations of Atlas's reflective membrane. They modeled light bending, diffraction, and interference across the comet's surface, attempting to reproduce the holographic distortions seen in real time. No existing model could fully replicate the observations. The precision, the timing, and the layered complexity suggested a design far beyond natural processes known to humanity. Some researchers, whispering in the quiet of the night, speculated that the comet might have been designed to interact with light and observers, an interstellar mirror extending across space and imagination. The scientific discourse also turned to function. What purpose could a reflective holographic surface serve? Some proposed that it could be a natural energy management system, reflecting excess solar radiation to prevent thermal degradation. Others, more speculative, considered it might be a form of signaling, a medium for interstellar communication, or even a sensor array designed to respond to observation. Every hypothesis was tempered with caution. No definitive conclusions could be drawn, yet the mere possibility of purpose electrified the community. Observers began to notice subtle correlations with Atlas's previously recorded pulses. The light-bending distortions fluctuated in rhythm with the comet's hum, aligning temporally with low-frequency emissions that had baffled scientists since its arrival. Patterns appeared consistent across wavelengths, from infrared to visible light, suggesting that the reflective membrane and the comet's energetic pulses were integrated systems, synchronized in ways that hinted at design or intent. The more data accumulated, the clearer the impression that Atlas was no ordinary object. Meanwhile, the human reaction was as diverse as the phenomenon itself. In quiet observatories, researchers described a sense of awe, even reverence. The comet's mirrored surface seemed to engage the imagination, drawing observers into contemplation of the universe's mysteries. Some wrote in personal journals about seeing shapes in the reflections, patterns that shifted as they watched, almost like messages embedded in light. Others approached it from purely analytical perspectives, meticulously plotting angles, measuring refractive indices, and cataloging every observed distortion. Across the globe, discussions expanded into philosophy and art. Poets wrote about the mirror in the void, describing it as a celestial canvas, reflecting not the sun, but something unseen, a consciousness, a memory, or perhaps a message left by forces beyond human comprehension. Visual artists created renderings of the comet's reflective structures, imagining how light could interact with crystalline surfaces in the emptiness of space. The effect was subtle yet profound. Atlas had transcended the scientific, becoming a muse, a mystery that bridged observation, imagination, and contemplation. Even as fascination grew, caution remained. Scientists repeatedly emphasized that interpretations must avoid anthropomorphism. The apparent mirror could be the result of complex thermodynamic processes, interactions with solar radiation, or natural crystallization under extreme conditions. Yet the extraordinary alignment of the reflective structures with Atlas's hum and previously observed patterns resisted simple explanations. Something about the comet defied the known laws of chance, demanding attention and humility from those studying it. Satellite and probe instrumentation added further nuance. Space-based telescopes, free from atmospheric distortion, revealed fine details of the crystalline membrane. Layered facets reflected light in repeating geometric sequences, creating interference patterns that shifted with the comet's rotation. Analysis suggested that the structure could self-adjust, responding to environmental conditions, an emergent property that was simultaneously natural and seemingly intentional. Researchers found themselves balancing wonder with caution, unable to fully categorize the phenomenon within existing scientific frameworks. Discussions of agency began to surface. Could the mirrored surface serve a functional purpose, interacting with the solar system, or even with human-made instruments? Some hypothesized that Atlas might be capable of responding to observation, modulating reflections to create subtle signals. Others cautioned that such interpretations risked projecting intention where physics alone could suffice. Yet the combination of structure, symmetry, and light manipulation was so pronounced that the possibility lingered. A comet behaving as more than an object, a mirror reflecting not light but perhaps thought, curiosity, or intent. Night after night, observers continued their vigil. Each pass revealed new details, subtle shifts in angle, faint changes in reflective intensity, and slight variations in holographic projections. The comet's mirrored surface seemed to evolve over time, becoming more coherent, more structured, more pronounced. It was as if the object itself were growing, learning or at least responding to forces both internal and external. Every observation reinforced the sense that Atlas had transcended conventional definition, moving beyond cometary identity into the realm of something unknowable yet profoundly compelling. In the quiet of laboratories, observatories and homes, a sense of connection emerged. The mirrored surface, the crystalline layers, and the faint holographic distortions were no longer just scientific curiosities. They became symbols of humanity's engagement with the cosmos. Observers felt a profound intimacy with the comet, a recognition that in watching, cataloging, and contemplating, they were participating in a dialogue across space, time, and matter. And as Atlas drifted onward, continuing its interstellar voyage, the mirrored membrane persisted, reflecting faint light in angles and intensities that suggested purpose. The comet, once merely a traveler through the solar system, had become something more, a mirror in the void, an enigmatic interface between the universe and those who dared to observe it, a quiet reminder that the cosmos often communicates in ways beyond comprehension, waiting only for those patient enough to notice. The universe, vast and indifferent, has a rhythm all its own. Stars pulse, planets orbit, comets traverse their predetermined paths. And yet for a brief moment in April 2025, humanity experienced a silence unlike any before. It was not the ordinary quiet of space, the low hum of cosmic background radiation, or the intermittent crackle of solar flares. This silence was deliberate, almost deliberate enough to feel like an interlude orchestrated by the cosmos itself. For weeks, astronomers, engineers, and enthusiasts had tracked I Atlas with a mix of reverence and obsession. Its pulses had become familiar, almost comforting, a heartbeat in the vast darkness. Its mirrored surface had dazzled instruments and imaginations alike. Voyager had whispered back. The comet had interacted, illuminated, reflected, and teased, and then in the blink of an eye it disappeared. Telescopes pointed toward the comet's predicted coordinates, found nothing. Instruments designed to capture even the faintest glimmer of its reflective membrane returned only blank readings. The hum, once so persistent in low-frequency bands, vanished entirely. It was as if Atlas had stepped back from observation, leaving humanity suspended in a void of uncertainty. Engineers double-checked equipment, recalibrated receivers, and scanned other regions of the sky. There was no glitch, no solar interference, no ordinary explanation. Silence had fallen, absolute and thorough. Official statements were careful, measured, and oddly mundane. Space agencies cited atmospheric interference, unexpected solar activity, or instrument recalibration. Press releases reassured the public that nothing was amiss, that observations would resume shortly. Yet the language was cautious, clipped, evasive. It did not match the significance of what had been observed just days earlier. Inside, however, a different narrative quietly circulated. Whispers spoke of data suppression, deliberate blackouts, and coordination between agencies that rarely shared sensitive information. The silence, some argued, was not a natural phenomenon. It was a controlled pause, a deliberate curtain drawn over human curiosity. In private forums and encrypted channels, scientists expressed both frustration and fascination. How could an object that had revealed so much, that had seemingly communicated through pulses, light, and mirrored reflections, vanish entirely from observation? Some feared that Atlas had left temporarily, retreating beyond the instrument's reach. Others speculated that its reflective membrane had shifted orientation or evolved in a way that deflected all current detection methods. A few whispered the unthinkable, that the comet, aware of human scrutiny, had chosen to conceal itself. The sudden absence transformed routine observation into anxious vigilance. Night after night, observatories scanned the predicted paths, sweeping wide arcs of space, capturing terabytes of data. Each session yielded the same result: nothing. Every detector, from radio arrays to infrared spectrographs, reported empty space. The void was now heavy with expectation, a silence pregnant with unasked questions. Amateur astronomers, once thrilled by glimpses of the comet, now shared images of empty star fields, overlaid with annotations marking where Atlas had been predicted to appear. These blank frames were haunting, like photographs of a stage after the actors had vanished. As the days lengthened, speculation deepened. Some proposed that the comet had accelerated to an unexpected velocity, leaving the inner solar system too quickly for terrestrial instruments to track. Calculations were attempted, trajectories revised, but every model came up short. The disappearance was not just sudden. It was precise, leaving no trace of its path, as if it had folded space around itself or exploited hidden corridors within gravitational fields. Even the most rigorous simulations failed to reproduce the observed blackout. Inside research facilities, tension grew palpable. Analysts whispered to one another, eyes flicking to live feeds, recalculating coordinates and checking historical data. Theories circulated: electromagnetic shielding, temporary cloaking, energy absorption into the interstellar medium. Each idea carried a grain of plausibility and a weight of impossibility. The more scientists examined the data, or lack thereof, the more it became apparent that something extraordinary had occurred. Silence was not a passive state in this context. It was an event, a phenomenon with consequences. The blackout also ignited curiosity in unexpected quarters. Writers, philosophers, and dreamers began speculating on the metaphorical implications of absence. Silence, they argued, is itself a form of communication. The universe had imposed a pause, a reflective interlude forcing humanity to confront its expectations, limitations, and assumptions. Observing the absence of Atlas was now as significant as observing its presence. It was a reminder that even in the pursuit of knowledge, the cosmos reserves its mysteries, and that some answers arrive on their own terms, not ours. Meanwhile, communications with spacecraft continued without anomaly. Voyager 2, long thought to be the only other participant in this cosmic dialogue, transmitted faint signals according to schedule. Yet even these were carefully analyzed for anomalies that might hint at Atlas's influence. Some engineers noted subtle deviations in expected telemetry, minor fluctuations in voltage, or timing offsets that could not easily be explained. Whether these were related to the blackout or merely artifacts of aging hardware remained uncertain, but the possibility suggested a larger, interconnected phenomenon that spanned both human and interstellar-made objects. Across governments and space agencies, the blackout prompted quiet deliberation. There were reports of internal meetings, coordination between monitoring stations, and discussions of contingency plans. The comet, once an observable anomaly, had become an unknown factor, a variable that could no longer be tracked with certainty. Security, protocol, and public messaging became intertwined with scientific inquiry, each cautious of revealing too much, yet unable to ignore the profound implications. Humanity was confronted not only with the mystery of Atlas, but with the limits of observation itself. As the week stretched into two, amateur communities adapted. Enthusiasts programmed automated arrays to scan larger swaths of sky, hoping to capture even the faintest remnant of the comet. Citizen scientists shared algorithms designed to filter cosmic noise, searching for echoes of Atlas's pulse frequency in the static of radio feeds. While these efforts produced no confirmed detections, the collective endeavor became a meditation of its own kind, a shared act of patient observation, a testament to human persistence in the face of cosmic silence. The blackout also altered perception. What had been familiar, the hum, the mirrored surface, the reflective patterns, was now remembered in fragments reconstructed from prior observations, photographs, and recorded spectra. The memory of Atlas lingered as a presence rather than a physical entity. In its absence, it became a mirror, reflecting human curiosity, obsession, and awe back upon those who had watched it. Silence in this sense was not emptiness. It was the echo of discovery, magnified by the imagination and the mind's longing for comprehension. Philosophers and theorists began framing the blackout in metaphorical terms. Some wrote of cosmic pedagogy, the notion that the universe teaches through absence as much as through presence. Others framed it as a liminal experience, a threshold between known and unknown, a pause in which humanity could reflect on its own assumptions about observation, causality, and the nature of intelligence beyond Earth. In quiet observatories, the act of waiting became a form of engagement, a contemplative practice intertwined with science. Despite the tension, there was a quiet reassurance in the continuity of observation. Instruments remained pointed, data logs continued, and humanity maintained vigilance. The blackout, as unnerving as it was, did not signify the end of discovery. Rather, it emphasized that the cosmos moves on its own timeline, independent of expectation, requiring patience, humility, and attentiveness. Atlas had withdrawn, yet its influence persisted in the minds and instruments of those who had witnessed it. By the end of the third week, faint anomalies began to appear once more. Observers noted irregularities in background radiation readings, subtle shifts in optical measurements, and minor fluctuations in low-frequency radio noise. While none could be definitively attributed to the comet, the sense of anticipation was palpable. The universe, it seemed, had paused deliberately, orchestrating a silent interlude before the next act of revelation. For those watching, the lesson was clear. Silence itself carries information, mystery, and the promise of what is yet to be discovered. In the quiet night, as telescopes trained upon empty space and data streamed into servers across the globe, the absence of Atlas became its own story, a narrative of patience, observation, and wonder. Humanity was reminded that the cosmos is not merely a backdrop for inquiry, but an active participant in the unfolding drama. The data blackout, though frustrating, was also profound. It challenged assumptions, inspired creativity, and deepened the sense of connection between observer and the observed. And so as April faded into May, humanity waited. The instruments stood ready, the networks of observers remained vigilant, and the memory of Atlas, its mirrored surface, its hum, its pulses, lingered in collective consciousness. Silence had fallen, but it was not empty. It was deliberate, charged with expectation, a pause pregnant with the possibilities of revelation yet to come. In the dark expanse of space, the cosmos had drawn its curtain, leaving humanity to ponder, to speculate, and to watch patiently, knowing that the next act could arrive at any moment, with lessons that would forever reshape understanding. Curiosity is, perhaps, humanity's most defining trait. It drives us to peer into the night sky, to dissect the smallest particles, to question the nature of existence itself. It compels us to push beyond boundaries, to chart territories both terrestrial and cosmic. Yet in April 2025, As 3i Atlas traversed the solar system and revealed anomalies beyond expectation, curiosity met an unforeseen consequence: the realization that not every phenomenon conforms to human patterns. Not every signal fits neatly into the frameworks of knowledge we hold dear. For generations, science has been the language through which we translate the universe's behavior into comprehensible terms. Patterns are identified, repetitions measured, laws formulated. These frameworks provide certainty, a scaffold upon which understanding is built. Yet Atlas, with its deliberate trajectory, mirrored surfaces and cryptic pulses, challenged every assumption. It was a phenomenon that could not be easily catalogued, predicted, or repeated. Its existence forced scientists and observers alike to confront a reality where certainty was provisional and the unknown was absolute. The initial exhilaration of discovery gradually gave way to unease. Researchers who had spent weeks, months, or even years tracking the comet found themselves facing skepticism, even ridicule. Peer-reviewed journals hesitated to publish findings that challenged conventional astrophysics. Funding committees, uncomfortable with phenomena that could not be neatly quantified, began reallocating grants, emphasizing safer, more predictable projects. Laboratories once buzzing with collaboration felt quieter, as whispers of caution replaced open enthusiasm. The very act of pursuing the unknown now carried professional risk, yet the drive to understand persisted. Small teams, often working outside institutional oversight, continued to study Atlas's trajectory, its pulses, and its reflective membrane. Private networks of radio astronomers, independent mathematicians, and amateur astronomers became vital. They shared datasets, cross-referenced observations, and debated interpretations in hushed tones, aware that mainstream recognition was unlikely. In this quiet persistence lay a paradox. Humanity's thirst for certainty had met the infinite unknown, and the result was both frustration and profound awe. Ethical dilemmas emerged as well. Governments and agencies debated whether to release data in full or restrict access to prevent public panic. The potential implications of Atlas's behavior, an interstellar object seemingly capable of responding to observation, were staggering. Could it be artificial, or simply a natural anomaly beyond our understanding? Either conclusion challenged deeply held assumptions about humanity's place in the cosmos. Information was tightly controlled, and the veil of secrecy fostered tension between scientific integrity and national security concerns. Public perception became another arena of consequence. Amateur astronomers and online communities, disconnected from official narratives, speculated wildly. Theories ranged from interstellar intelligence to exotic physics, and discussions often veered into philosophical and metaphysical territory. Yet the scientific community, constrained by the weight of evidence or lack thereof, had to respond carefully, walking a delicate line between acknowledgement and caution. Curiosity, once an unambiguously celebrated trait, now carried social and professional risk. Within the academic sphere, debates unfolded in quiet corridors and private correspondence. Some scholars argued that the pursuit of phenomena like Atlas was essential, regardless of skepticism or funding pressures. Others contended that resources should be redirected toward reproducible research, where patterns could be confirmed and verified. These debates were not merely academic. They reflected a tension between the human desire to explore and the practical realities of institutional science. The unknown, once a source of inspiration, had become a source of unease. Yet the consequences of curiosity were not solely restrictive. In parallel to professional challenges, the comet's enigmatic behavior inspired a renaissance of creativity. Artists, writers, and philosophers interpreted the events as a meditation on humanity's relationship with the cosmos. Poets described the mirrored membrane as a reflection of human longing, the pulses as whispers of the universe, speaking directly to those who dared to listen. Philosophers framed the blackout and the subsequent observations as a lesson in humility, that even our most sophisticated instruments and brightest minds are limited when confronting phenomena that transcend conventional understanding. Scientists also began to reconsider fundamental definitions. What does it mean for something to be natural? Is it merely the product of physical processes, or does it encompass forms and behaviors we have yet to comprehend? Atlas's deliberate patterns, reflective structures, and interactions with human-made probes challenged the traditional boundary between natural and artificial. Researchers were forced to expand their conceptual frameworks, acknowledging that the universe might operate on levels of complexity and intent beyond our current comprehension. This re-evaluation extended to methodology. Observational protocols, data collection standards, and analytical models all came under scrutiny. How should one study an object that refuses categorization, whose behavior defies repetition, whose presence is ephemeral yet impactful? The experience of Atlas became a case study in adaptive inquiry, an exercise in embracing uncertainty, in valuing subtlety, and in remaining patient amid the unknown. It was a lesson that discovery is not always linear, and understanding is rarely absolute. Even at the individual level, scientists faced psychological consequences. The comet's unpredictability, the professional pushback, and the gap between observation and explanation created a sense of cognitive dissonance. Many described late nights at observatories, staring at screens, feeling both elation and frustration, as if the universe were teasing understanding, yet withholding it entirely. In these moments, curiosity became simultaneously exhilarating and unsettling, a reminder that the quest for knowledge is as much an internal journey as an external one. The societal implications were equally profound. Atlas had captured public imagination, yet the silence, the blackout, and the complexity of the observations highlighted humanity's limitations. Schools and universities reported heightened interest in astronomy, physics, and space science, yet educators had to grapple with explaining phenomena that had no clear resolution. In homes and classrooms, the comet became a symbol of the balance between curiosity and humility, excitement and patience, observation and interpretation. Humanity's collective gaze was drawn outward, even as understanding remained tantalizingly just out of reach. Curiosity, it became clear, is not without cost. It invites wonder, yes, but also scrutiny, resistance, and the discomfort of confronting the unknown. It demands persistence in the face of ambiguity, courage when certainty is impossible, and a willingness to tolerate both professional and personal uncertainty. The story of Atlas was, in a sense, the story of humanity itself, seeking patterns in the void, reaching for understanding beyond the immediate, and grappling with the tension between what is known and what remains forever mysterious. In quiet moments, researchers reflected on the broader lesson. The universe does not operate to human schedules, nor does it adhere to our definitions. Its phenomena are often unrepeatable, unpredictable, and infinitely nuanced. Atlas, with its mirrored membrane, low-frequency hum, and interactions with Voyager, exemplified this truth. Humanity, through curiosity, had glimpsed a fragment of the extraordinary, and in doing so, was reminded of both its potential and its limitations. The consequences extended beyond science into philosophy and culture. Writers speculated on the nature of intelligence, perception, and agency in the cosmos. Musicians and sound engineers attempted to replicate Atlas's pulses, transforming data into melodies that echoed the rhythm of the universe. Philosophical discussions arose around the ethics of observation. What responsibility does humanity bear when studying phenomena that may possess unknown levels of complexity or consciousness? Curiosity, it seemed, was as much an ethical endeavor as an intellectual one. Over time, some researchers found solace in the act of observation itself, regardless of external validation. Nights spent monitoring the comet, analyzing subtle pulses, or modeling the mirrored surface became meditative exercises. Curiosity, once a professional mandate, transformed into a personal practice of engagement with the unknown. In this sense, the discomfort of uncertainty became a conduit for reflection, humility, and reverence. The silence and ambiguity surrounding Atlas, far from discouraging, deepened the connection between observer and cosmos. Even as debates continued about funding, legitimacy, and methodology, the human spirit of inquiry endured. Smaller teams persisted in documenting every observable phenomenon, in cross-referencing telemetry with ground-based data, in modeling optical and energetic interactions with precision. Every pulse, every reflection, every anomaly was catalogued and scrutinized, not necessarily for immediate understanding, but for the assurance that the pursuit itself mattered. Curiosity, when embraced fully, became both a journey and a reward. In the end, the consequences of curiosity were manifold. It challenged institutional norms, redefined professional and personal boundaries, inspired art and philosophy, and forced a re-examination of the very definitions upon which science relies. It illuminated the tension between what is known and what remains elusive, demonstrating that knowledge is never absolute, and that mystery, far from being an obstacle, is a catalyst for growth, reflection, and imagination. Telescopes pointed toward the comet's predicted coordinates found nothing. Instruments designed to capture even the faintest glimmer of its reflective membrane returned only blank readings. The hum, once so persistent in low-frequency bands, vanished entirely. It was as if Atlas had stepped back from observation, leaving humanity suspended in a void of uncertainty. Engineers double-checked equipment, recalibrated receivers, and scanned other regions of the sky. There was no glitch, no solar interference, no ordinary explanation. Silence had fallen, absolute and thorough. Official statements were careful, measured, and oddly mundane. Space agencies cited atmospheric interference, unexpected solar activity, or instrument recalibration. Press releases reassured the public that nothing was amiss, that observations would resume shortly. Yet the language was cautious, clipped, evasive. It did not match the significance of what had been observed just days earlier. Inside, however, a different narrative quietly circulated. Whispers spoke of data suppression, deliberate blackouts, and coordination between agencies that rarely shared sensitive information. The silence, some argued, was not a natural phenomenon. It was a controlled pause, a deliberate curtain drawn over human curiosity. In private forums and encrypted channels, scientists expressed both frustration and fascination. How could an object that had revealed so much, that had seemingly communicated through pulses, light, and mirrored reflections, vanish entirely from observation? Some feared that Atlas had left temporarily, retreating beyond the instrument's reach. Others speculated that its reflective membrane had shifted orientation or evolved in a way that deflected all current detection methods. A few whispered the unthinkable, that the comet, aware of human scrutiny, had chosen to conceal itself. The sudden absence transformed routine observation into anxious vigilance. Night after night, observatories scanned the predicted paths, sweeping wide arcs of space, capturing terabytes of data. Each session yielded the same result: nothing. Every detector, from radio arrays to infrared spectrographs, reported empty space. The void was now heavy with expectation, a silence pregnant with unasked questions. Amateur astronomers, once thrilled by glimpses of the comet, now shared images of empty star fields, overlaid with annotations marking where Atlas had been predicted to appear. These blank frames were haunting, like photographs of a stage after the actors had vanished. As the days lengthened, speculation deepened. Some proposed that the comet had accelerated to an unexpected velocity, leaving the inner solar system too quickly for terrestrial instruments to track. Calculations were attempted, trajectories revised, but every model came up short. The disappearance was not just sudden. It was precise, leaving no trace of its path, as if it had folded space around itself or exploited hidden corridors within gravitational fields. Even the most rigorous simulations failed to reproduce the observed blackout. Inside research facilities, tension grew palpable. Analysts whispered to one another, eyes flicking to live feeds, recalculating coordinates and checking historical data. Theories circulated: electromagnetic shielding, temporary cloaking, energy absorption into the interstellar medium. Each idea carried a grain of plausibility and a weight of impossibility. The more scientists examined the data, or lack thereof, the more it became apparent that something extraordinary had occurred. Silence was not a passive state in this context. It was an event, a phenomenon with consequences. The blackout also ignited curiosity in unexpected quarters. Writers, philosophers, and dreamers began speculating on the metaphorical implications of absence. Silence, they argued, is itself a form of communication. The universe had imposed a pause, a reflective interlude forcing humanity to confront its expectations, limitations, and assumptions. Observing the absence of Atlas was now as significant as observing its presence. It was a reminder that even in the pursuit of knowledge, the cosmos reserves its mysteries, and that some answers arrive on their own terms, not ours. Meanwhile, communications with spacecraft continued without anomaly. Voyager 2, long thought to be the only other participant in this cosmic dialogue, transmitted faint signals according to schedule. Yet even these were carefully analyzed for anomalies that might hint at Atlas's influence. Some engineers noted subtle deviations in expected telemetry, minor fluctuations in voltage, or timing offsets that could not easily be explained. Whether these were related to the blackout or merely artifacts of aging hardware remained uncertain, but the possibility suggested a larger, interconnected phenomenon that spanned both human and interstellar-made objects. Across governments and space agencies, the blackout prompted quiet deliberation. There were reports of internal meetings, coordination between monitoring stations, and discussions of contingency plans. The comet, once an observable anomaly, had become an unknown factor, a variable that could no longer be tracked with certainty. Security, protocol, and public messaging became intertwined with scientific inquiry, each cautious of revealing too much, yet unable to ignore the profound implications. Humanity was confronted not only with the mystery of Atlas, but with the limits of observation itself. As the week stretched into 2, amateur communities adapted. Enthusiasts programmed automated arrays to scan larger swaths of sky, hoping to capture even the faintest remnant of the comet. Citizen scientists shared algorithms designed to filter cosmic noise, searching for echoes of Atlas's pulse frequency in the static of radio feeds. While these efforts produced no confirmed detections, the collective endeavor became a meditation of its own kind, a shared act of patient observation, a testament to human persistence in the face of cosmic silence. The blackout also altered perception. What had been familiar, the hum, the mirrored surface, the reflective patterns, was now remembered in fragments reconstructed from prior observations, photographs, and recorded spectra. The memory of Atlas lingered as a presence rather than a physical entity. In its absence, it became a mirror, reflecting human curiosity, obsession, and awe back upon those who had watched it. Silence in this sense was not emptiness. It was the echo of discovery, magnified by the imagination and the mind's longing for comprehension. Philosophers and theorists began framing the blackout in metaphorical terms. Some wrote of cosmic pedagogy, the notion that the universe teaches through absence as much as through presence. Others framed it as a liminal experience, a threshold between known and unknown, a pause in which humanity could reflect on its own assumptions about observation, causality, and the nature of intelligence beyond Earth. In quiet observatories, the act of waiting became a form of engagement, a contemplative practice intertwined with science. Despite the tension, there was a quiet reassurance in the continuity of observation. Instruments remained pointed, data logs continued, and humanity maintained vigilance. The blackout, as unnerving as it was, did not signify the end of discovery. Rather, it emphasized that the cosmos moves on its own timeline, independent of expectation, requiring patience, humility, and attentiveness. Atlas had withdrawn, yet its influence persisted in the minds and instruments of those who had witnessed it. By the end of the 3rd week, faint anomalies began to appear once more. Observers noted irregularities in background radiation readings, subtle shifts in optical measurements, and minor fluctuations in low-frequency radio noise. While none could be definitively attributed to the comet, the sense of anticipation was palpable. The universe, it seemed, had paused deliberately, orchestrating a silent interlude before the next act of revelation. For those watching, the lesson was clear. Silence itself carries information, mystery, and the promise of what is yet to be discovered. In the quiet night, as telescopes trained upon empty space and data streamed into servers across the globe, the absence of Atlas became its own story, a narrative of patience, observation, and wonder. Humanity was reminded that the cosmos is not merely a backdrop for inquiry, but an active participant in the unfolding drama. The data blackout, though frustrating, was also profound. It challenged assumptions, inspired creativity, and deepened the sense of connection between observer and the observed. And so as April faded into May, humanity waited. The instruments stood ready, the networks of observers remained vigilant, and the memory of Atlas, its mirrored surface, its hum, its pulses, lingered in collective consciousness. Silence had fallen, but it was not empty. It was deliberate, charged with expectation, a pause pregnant with the possibilities of revelation yet to come. In the dark expanse of space, the cosmos had drawn its curtain, leaving humanity to ponder, to speculate and to watch patiently, knowing that the next act could arrive at any moment, with lessons that would forever reshape understanding. Curiosity is, perhaps, humanity's most defining trait. It drives us to peer into the night sky, to dissect the smallest particles, to question the nature of existence itself. It compels us to push beyond boundaries, to chart territories both terrestrial and cosmic. Yet in April 2025, as 3i Atlas traversed the solar system and revealed anomalies beyond expectation, curiosity met an unforeseen consequence: the realization that not every phenomenon conforms to human patterns. Not every signal fits neatly into the frameworks of knowledge we hold dear. Cultural response mirrored scientific and philosophical reflection. Writers and filmmakers drew inspiration from the narrative of Atlas as a traveler, a mirror and a teacher. Music composers created pieces that incorporated its pulses, allowing listeners to experience rhythm and resonance beyond mere auditory perception. Visual artists explored the mirrored surface, the holographic distortions, and the interplay of light in representations that evoked both wonder and contemplation. The comet became a touchstone for collective imagination, bridging disciplines and mediums in a shared act of curiosity. Even as human understanding remained incomplete, Atlas's influence endured. Its mirrored surface, intermittent pulses, and reflective interactions offered a persistent invitation to look, listen, and reflect. Humanity was reminded that knowledge is never absolute, that curiosity is as much a journey of the mind and spirit as a collection of empirical facts, and that wonder itself is a profound form of engagement with the universe. The comet's presence, fleeting yet enduring in memory, reinforced the delicate balance between observation and interpretation, between the measurable and the ineffable. In the quiet hours of night, when observatories and homes alike were bathed in soft artificial light, humans reflected on their relationship with the cosmos. Atlas, hovering in the void, had become more than an interstellar visitor. It was a teacher, a mirror, and a prompt for contemplation. Its journey reminded observers of their own smallness, the limitations of perception, and the infinite layers of complexity that make up both space and consciousness. In pondering the comet, humanity pondered itself. By the time April gave way to May, discussions had stabilized into a delicate equilibrium. Scientists continued rigorous analysis, philosophers engaged in meditation and debate, and artists continued to translate observations into human experience. All recognized that Atlas's significance extended beyond technical anomalies. It was a reflection of curiosity itself, a reminder that engagement with the unknown is a shared human experience, simultaneously scientific, philosophical, and spiritual. And so, as night deepened and telescopes turned skyward, the comet remained a silent interlocutor. It offered no direct answers, only reflections, pulses, and glimpses of patterns that invited observation and introspection. In its presence, humanity learned to watch patiently, think deeply, and wonder freely. Atlas became more than a comet. It became a mirror for the mind and spirit, a cosmic meditation bridging knowledge, imagination, and humility. The movement of 3i Atlas continued to defy understanding. Even as humanity's instruments reached levels of precision previously unimagined, every telescope, radar array, and spacecraft sensor returned data that seemed to contradict fundamental expectations. Astronomers plotted its trajectory, cross-referenced multiple observation points, and applied centuries of celestial mechanics, only to find that traditional models failed to account for its behavior. At times, it appeared to accelerate, decelerate, or shift course without any apparent force. The comet's path was a puzzle that refused to yield its solution, a cosmic riddle suspended in the quiet of space. Physicists, both established and fringe, debated what mechanisms could produce such anomalies. Some proposed exotic propulsion methods, invoking plasma jets or gravitational slingshots unseen in prior cometary behavior. Others speculated on magnetic or electromagnetic interactions that could subtly manipulate its trajectory, but no known field could explain the scale, precision, or timing of the observed movements. The data seemed to whisper that the universe was more intricate than textbooks had ever suggested, that even Newton's laws, so elegantly predictive for centuries, might be stretched to accommodate an anomaly that could rewrite understanding. Among the scientific community, the divergence of interpretations grew stark. Traditional astrophysicists focused on replicable models, adhering strictly to the bounds of observed physics. They approached Atlas as an outlier to be catalogued, analyzed, and, where possible, explained within existing paradigms. Fringe theorists, however, ventured into realms that were speculative yet compelling, suggesting that the comet's motion might not be entirely attributable to any conventional forces. They considered possibilities that bordered on the metaphysical, space itself bending, time dilation localized along its path, or even interactions with unseen dimensions. Each hypothesis carried a kernel of plausibility, yet remained tantalizingly unprovable. The idea that space itself might bend around Atlas captivated a small subset of physicists. It implied a subtle, almost imperceptible warping of spacetime, a localized distortion that guided the comet along its unpredictable path. Such a concept, while mathematically intriguing, presented profound philosophical implications. If space could flex and curve in response to an object, then perhaps motion, causality, and observation were not as absolute as previously assumed. The cosmos, it seemed, had room for behaviors that challenged the very notion of predictability, revealing a universe alive with subtle, hidden choreography. The data itself was both illuminating and frustrating. Every observation, from infrared spectrographs to radio arrays, provided fragments of truth that begged to be assembled into a coherent model. Pulses, reflections, shifts in velocity, ionized trails and low-frequency hums formed a complex mosaic. Patterns emerged, but each discovery led to new contradictions. Analysts found themselves revisiting prior assumptions, questioning calibration, and recalculating trajectories in an iterative cycle of fascination and doubt. The comet's motion became a meditation on uncertainty, a reminder that knowledge is provisional and understanding is often asymptotic. This uncertainty extended beyond science into philosophy. What did it mean for an object to defy the expectations of centuries of observation? Did Atlas reveal limits in human comprehension, or did it hint at principles yet undiscovered? Some philosophers suggested that the comet functioned as a mirror, reflecting humanity's desire to impose order on a universe that may not yield to neat categorization. Its motion, enigmatic and precise, embodied the tension between knowledge and mystery, between observation and interpretation, and between the desire for certainty and the acceptance of ambiguity. Observers began to meditate on the experiential dimension of tracking Atlas. Nights spent watching screens, plotting coordinates and comparing datasets were no longer purely scientific exercises. They became acts of contemplation. Each unexpected shift in the comet's trajectory prompted reflection on the scale of space, the fragility of human models, and the humility inherent in seeking understanding. The comet, by eluding prediction, taught patience as much as it demanded calculation, and in doing so, reminded humanity that observation is a dialogue, not a conquest. In public imagination, Atlas became a symbol of the unresolved. Writers, musicians, and artists drew inspiration from its inexplicable movements, exploring themes of uncertainty, fluidity, and cosmic rhythm. Stories depicted the comet as a dancer, tracing steps unseen, or a teacher guiding humanity through lessons in humility and attentiveness. Composers translated pulse data into harmonies, attempting to hear the subtle logic of its motion. Visual artists recreated its mirrored surface and shifting path, turning scientific observation into aesthetic meditation. In these interpretations, the unresolved equation became not a failure of understanding, but a source of creativity and wonder. For engineers and data analysts, Atlas posed a methodological challenge. How could one design predictive models when the object itself seemed to evade constraints? Algorithms that worked for planetary orbits failed to converge. Simulations produced chaotic divergences with every small variation in initial conditions. Yet each failure revealed information, subtle consistencies in acceleration, timing, and reflection hinted at principles not yet formalized. The comet's trajectory became a living puzzle, an evolving problem set that demanded both rigor and imagination, precision and openness to the unknown. Speculation about potential mechanisms expanded into thought experiments that blended physics with philosophy. Could the comet be exploiting unknown aspects of quantum mechanics at macroscopic scales? Might it interact with fields or particles we have yet to detect? Some considered the possibility that its reflective membrane, low-frequency hum, and periodic pulses were integrated components of a complex, self-organizing system, one capable of subtle self-propulsion or even information exchange. Each hypothesis, while unconfirmed, underscored a critical truth. Atlas challenged assumptions, revealing that the cosmos may operate on principles beyond the reach of current instruments. Amateur astronomers, meanwhile, contributed observations that became increasingly valuable. Their distributed networks, capable of rapid and diverse data collection, sometimes detected nuances missed by larger instruments. Some noted microshifts in apparent trajectory, correlated with pulses of electromagnetic activity, while others observed faint optical distortions inconsistent with natural phenomena. Collectively, these contributions painted a portrait of an object that was both observable and elusive, a paradox that mirrored the duality of knowledge and mystery. The psychological impact on scientists was profound. Long nights spent tracking the comet, recalculating and debating models, led to a heightened awareness of both limitation and possibility. They confronted the uncomfortable reality that even with the most sophisticated tools, some phenomena may evade complete understanding. The unresolved equation became a meditation on human humility, a reminder that intelligence, curiosity, and observation, while powerful, are not omnipotent. It prompted reflection on the nature of inquiry itself and on the ethical and philosophical responsibility inherent in interpreting phenomena that exceed comprehension. As the weeks and months unfolded, the unresolved nature of Atlas's motion remained a persistent tension. Scientific journals published papers documenting anomalies, mathematical analyses, and speculative frameworks, but consensus remained elusive. Conferences devoted to interstellar objects became stages for vigorous debate, blending rigorous physics with theoretical explorations of space-time manipulation, unknown forces, and even the implications of advanced intelligence. The comet's behavior challenged participants to think expansively, to consider frameworks that incorporated both observable data and the unknown. In education, Atlas became a case study not only in physics but in epistemology, the study of how we know what we know. Students were taught that some systems defy simplification, that uncertainty is not weakness, and that observation, interpretation, and humility are intertwined. Exercises explored trajectory calculations that intentionally diverged, demonstrating how minor shifts in assumptions led to radically different predictions. In this way, the unresolved equation became a lesson in both scientific method and philosophical reflection, underscoring the limits and possibilities of human understanding. Cultural and artistic interpretations reinforced the metaphorical dimension. Writers framed Atlas's trajectory as a narrative of enigma, movement, and reflection. Musicians interpreted pulse data as rhythms with emotional resonance, creating immersive experiences that translated motion into feeling. Visual artists captured the shifting light and mirrored surface, blending observational accuracy with expressive abstraction. Across these domains, the comet's unresolved motion became a shared human experience, a reminder that some mysteries are as instructive in their ambiguity as in their clarity. As humanity continued to observe, model and reflect, a quiet truth emerged. The universe does not always yield to expectation. Atlas, through its defiance of conventional mechanics, illustrated that understanding is a process, not a destination. The unresolved equation, far from being a failure, was a testament to curiosity, patience, and imagination. It reminded humanity that exploration involves embracing uncertainty, observing attentively, and contemplating the broader implications of what lies beyond comprehension. In the final hours of observation before the comet receded from inner solar system view, astronomers reflected on the lessons learned. Atlas had pushed instruments to their limits, challenged models, and inspired philosophical and artistic inquiry. It had transformed the simple act of tracking an object into a meditation on the nature of knowledge, observation, and the infinite complexity of the cosmos. The unresolved equation remained not as a void, but as an invitation, a question poised in space, waiting for minds ready to engage, understand, and imagine. And so, as the comet drifted further into the depths of interstellar space, the mystery persisted. Its path, its pulses, its reflective surfaces, all remained unsolved, waiting for a civilization capable of fully grasping the implications. For now, Atlas was both a challenge and a teacher, a reminder that the universe contains patterns we have yet to decode, motions we have yet to predict, and truths that emerge slowly, patiently across time and space. The unresolved equation, silent yet insistent, beckoned humanity to look, to listen, and to wonder. Long after the final observations of 3I Atlas faded from active research logs, the memory of the comet lingered in ways both subtle and profound. It was no longer merely a celestial object, studied by instruments and plotted on charts. It had become a story whispered across generations, an emblem of curiosity, wonder, and the unending pursuit of knowledge. In observatories high on mountains, where telescopes once tracked its mysterious path, astronomers spoke of Atlas in hushed tones. They recounted nights spent watching its faint glow, nights filled with uncertainty, awe, and an almost sacred reverence for what they could not fully explain. Podcasts late at night carried stories of Atlas to listeners around the world. The voices of narrators, calm and reflective, described the comet's journey through the solar system, its mirrored membrane, the enigmatic pulses, and the subtle distortions it had cast into space. These tales were not merely technical recitations, they were meditative journeys, blending science with philosophy, curiosity with contemplation. Listeners, lying in dark rooms or under open skies, could feel themselves connected to the comet, as though its presence had left an echo in the night that continued to resonate long after it had passed. The comet's dual nature, part natural, part mysterious, remained central to the legend. Scholars debated whether Atlas had been an interstellar traveler shaped entirely by physics, or something more deliberate, a cosmic messenger in ways we could scarcely comprehend. Its path, its behaviors, and the faint hum that had pulsed through space were reminders that not all phenomena conform to human expectation. Even if its origin remained unknown, its influence on human thought and imagination was undeniable. It had rewritten the rules of observation, reminding humanity that the universe is not silent, but communicates in subtle, often indirect ways. In classrooms, educators framed Atlas not only as a case study in astrophysics, but as an invitation to explore the intersection of knowledge and humility. Students learned of orbital anomalies, pulse frequencies, and reflective surfaces, but also of the patience required to study what resists full understanding. They discussed the ethical dimensions of observation, the philosophical implications of encountering something truly alien, and the importance of wonder alongside measurement. Lessons extended beyond equations and charts, reaching into the human experience of curiosity, contemplation, and the limits of perception. Amateur astronomers, inspired by the comet, continued to watch the skies with renewed dedication. For them, Atlas was more than a scientific curiosity. It was a symbol of possibility, a reminder that even small instruments in quiet backyards could connect observers to the vast, mysterious cosmos. They shared observations online, reconstructed trajectories, and compared reflections of its faint pulse. In every glimmer and every calculation, the comet lived on, not merely as a past visitor, but as an enduring inspiration for those attuned to the subtleties of the night sky. The faint pulse that had once startled radio arrays continued to serve as a metaphor, if not a literal signal. Audio engineers, musicians, and sound artists translated its frequencies into compositions that echoed the rhythm of interstellar motion. The tones were slow, deliberate, almost hypnotic, capturing the cadence of a universe that moves in cycles beyond immediate comprehension. Listening to these pieces became a meditative practice, a way to inhabit the feeling of Atlas's presence, to sense the mystery it carried, and to reflect on the patience required to engage with the unknown. Writers and poets found new meaning in the comet's story. Some described Atlas as a traveler bearing messages across time and space, while others framed it as a mirror reflecting humanity's enduring desire to seek, observe, and understand. The mirrored membrane became symbolic of introspection, the pulses as the heartbeat of curiosity, and the intermittent blackouts as reminders that silence, too, is communicative. Literary interpretations emphasized the beauty of unresolved questions, portraying the comet as both a character and a catalyst, guiding humanity toward reflection rather than providing definitive answers. In the scientific community, Atlas continued to inspire cautious yet creative inquiry. Observational archives were revisited, models re-examined, and interdisciplinary approaches encouraged. Physicists discussed its trajectory, engineers analyzed pulse patterns, and astronomers refined detection methods. Even decades later, the comet's anomaly served as a reference point for evaluating new interstellar objects, reminding scientists that anomalies are opportunities for growth, not failures to be ignored. Its legacy was one of ongoing curiosity, shaping both methodology and mindset. The comet also influenced broader cultural and philosophical thought. Lecturers spoke of Atlas as a metaphor for the unknown forces shaping reality. The unseen aspects of its behavior became allegories for human experience. The decisions we cannot predict, the connections we cannot immediately understand, and the mysteries that shape life in subtle, persistent ways. Its story encouraged reflection on patience, humility, and the joy of discovery, reinforcing the idea that knowledge is a journey, not a destination. In homes around the world, families gazed at the night sky and shared stories of Atlas, sometimes pointing to faint lights in the distance and imagining the comet's slow passage. Grandparents recounted their experiences to children, blending scientific fact with legend, turning the comet into a symbol of exploration and imagination. This oral tradition, less formal than publications or podcasts, ensured that the memory of Atlas was embedded in human culture, a quiet thread connecting generations through curiosity, awe, and wonder. Astronomical societies held commemorations, not as celebrations of conquest, but as meditative gatherings. Observers, both professional and amateur, shared telescopic views, historical data, and reflections on the experience of witnessing a phenomenon that transcended ordinary understanding. These gatherings were marked by quiet reverence rather than spectacle, emphasizing contemplation over accolades. Atlas had taught humanity that engagement with the cosmos is less about domination and more about attentive listening, measured observation, and patient reflection. One of the most enduring legacies of Atlas was the recognition of the limits of perception. Humanity had learned that even with the most sophisticated instruments, some aspects of reality remain elusive, their meaning accessible only through reflection, imagination, and persistent inquiry. The comet's faint pulse, the mirrored surface, the inexplicable shifts, all were lessons in humility, reminders that observation alone is not sufficient to capture the full scope of existence. To witness Atlas was to encounter both the vastness of space and the depth of human curiosity. Even in solitude, individuals found resonance with the comet's story. Late-night walks under clear skies, quiet hours spent by telescope or radio receiver, and moments of reflection at windows overlooking city lights became personal meditations on mystery and connection. Atlas, in its absence, offered an enduring presence, a reminder that the cosmos speaks not only in light and frequency, but in silence, pattern, and persistence. To listen, one needed patience and attentiveness. To understand, one needed imagination and humility. The comet's narrative became a template for approaching new unknowns. As other interstellar objects were discovered, Atlas was referenced as a guide for how to observe, interpret, and respect phenomena that defy conventional explanation. It taught the importance of blending science with philosophy, measurement with reflection, and curiosity with ethical consideration. Future explorers, scientists, and thinkers drew inspiration from the lessons it imparted, understanding that the cosmos may always be partially inscrutable, and that the joy of discovery is inseparable from the humility of encountering the unknown. At the heart of these reflections was a quiet, enduring truth. The universe is not silent. Atlas had not communicated in words, yet it had conveyed something profound through movement, pulse, reflection, and absence. Its message was not literal but experiential. The cosmos is vast, alive with patterns and responsive to attentive observation. Those who had followed its journey carried the realization forward, understanding that communication exists in many forms, sometimes subtle, sometimes indirect, always requiring patience and openness to perceive. Even as decades passed and newer phenomena captured attention, the story of Atlas persisted. Its pulses, mirrored reflections, and anomalies continued to inspire wonder, teach humility, and spark creative thought. Scholars revisited archives, musicians and artists reinterpreted data, and the public continued to tell stories that blended science, philosophy, and imagination. In every instance, the comet reminded humanity that engagement with the cosmos is an ongoing conversation, one that stretches across time, space, and human consciousness. Some nights, under dark, star-filled skies, listeners claimed they could hear echoes of the faint pulse, as if the comet's heartbeat persisted beyond direct observation. Whether metaphorical or literal, the rhythm became emblematic of ongoing curiosity, a steady, persistent invitation to wonder, to reflect, and to remain attentive. It was a reminder that the universe has a cadence of its own, and that those willing to listen carefully may perceive truths otherwise hidden. Ultimately, Atlas became more than an interstellar object. It became a teacher, a muse, and a companion in the quiet moments of reflection. Its story encouraged humanity to look upward, not merely to catalogue but to contemplate, to measure, not only to know but to feel, to observe, not merely to analyze but to wonder. The comet's legacy was less about answers and more about engagement, a call to continue listening, dreaming and learning, and somewhere in the darkness, beyond the reach of human instruments, the faint pulse continued. It remained steady, rhythmic, almost imperceptible, like a heartbeat woven into the fabric of space. For those who paused, listened, and reflected, it offered continuity, a bridge across time and distance, an enduring whisper of the universe's presence. It waited patiently, ready for the next dreamer, the next curious observer, the next mind willing to contemplate the delicate, mysterious, and beautiful patterns that stretch across the cosmos. In the end, the night sky remembered Atlas, humanity remembered Atlas, and in that memory, both were forever intertwined, curiosity, wonder, reflection, and humility bound together in a quiet, cosmic meditation that echoed across generations,